Find a comfortable position. Let the shoulders drop a little. Let the breath come and go without managing it. Somewhere in the rainforest of Borneo, 200 feet above the ground, an orangutan has built a sleeping platform. She bent the branches inward toward a central point, wove them together with the systematic overlapping that creates a structure stiff enough to hold her weight, added a layer of smaller branches for cushioning, and in the last few minutes before the light went entirely, she tucked a few broad leaves over the edge to form a windbreak on the side, facing the evening breeze. The whole construction took her approximately 5 minutes. She has been building sleeping platforms every evening for 30 years, approximately 10,000 platforms across her life in the canopy, and the construction has the practiced ease of something done so many times that the hands know what to do before the mind has finished deciding. She settles into the platform. The forest around her is going dark from below, the light leaving the understory first and lingering in the canopy where she rests. A gibbon calls from somewhere to the east. A hornbill passes overhead, the whoosh of its wings audible in the evening quiet. Then stillness. The orangutan closes her eyes. Let yourself do the same if you like. Subscribe right now and help us reach 1,000 subscribers. Hit that button. It costs you nothing and it keeps this channel going. Drop a comment telling us where in the world you are watching from and what time it is. We read every single one. The orangutan is the largest arboreal animal on Earth. An adult male Bornean orangutan weighs between 50 and 90 kilograms and spends the majority of his life in the forest canopy, moving through it by a combination of brachiation, the arm-over-arm swinging that the orangutan shares with the gibbons, and the more deliberate quadrumanous climbing that uses all 4 limbs simultaneously to navigate the branching structure of the forest canopy. A 90-kilogram animal moving through a canopy whose branches do not reliably support 90 kilograms requires a degree of caution and a quality of spatial judgment that the research on orangutan movement has found to be among the most sophisticated in the arboreal mammals. The orangutan that swings from one branch to another at height is an animal that has assessed the branch's diameter, its angle, its likely breaking point, and the trajectory that will carry it safely to the next handhold, all in the fraction of a second available before the commitment to the movement must be made. The brain required for this assessment is large. The orangutan's encephalization quotient, the ratio of actual brain size to the expected brain size for a mammal of this body mass, is among the highest of any non-human primate. The large brain is not simply a computational tool for movement planning, though it is that. It is the organ of a cognitive system whose capabilities the research has spent decades characterizing and whose depth continues to exceed the expectations that any simple model of primate intelligence would generate. Let the image of the canopy settle into the background of the mind. 200 feet of layered green, the light filtering through in patterns that shift with the small movements of the leaves, the sounds of the forest's nightlife beginning to replace the sounds of the day. The orangutan is settled into her platform somewhere in that green, and the forest holds her the way the night holds everything that has found its place in it. The tool use of the orangutan is one of the most extensively documented examples of non-human tool behavior in the wild, and what the research has found in it goes beyond the simple use of objects to accomplish tasks. Orangutans in the wild have been documented using leaves as umbrellas in the rain, holding the broad leaf above the head during a downpour and discarding it when the rain stops. They use sticks to extract insects from tree holes and seeds from spiny fruit whose husks would injure the hands without the tool's mediation. They use leaves as gloves when handling prickly food items. They crumple leaves and use them as sponges to extract water from tree hollows that the mouth cannot reach. And they have been documented in the research populations of Swak Balimbing in Sumatra and at other field sites, using tools to make other tools, using a stone to sharpen a stick before using the stick as a digging implement, in a sequence of tool manufacture that requires a mental representation of the future use of the tool being made. The manufacture of tools for future use is cognitively demanding in a way that simple opportunistic tool use is not. An animal that uses a stick it has found to probe a hole is responding to the current situation with the current materials at hand. An animal that modifies a stick it has found to improve its effectiveness for a task it has not yet begun is maintaining a mental representation of the future situation. The whole, the stick's entry into it, the desired outcome, and working on the current material to produce a tool whose performance in that future situation will be better than the unmodified tool's performance would be. The mental time travel that this requires, the projection of the self into a future context whose details are represented accurately enough to guide current action, is a cognitive capability whose demonstration in a non-human animal is genuinely remarkable. The sleeping platform that the orangutan built at the beginning of this documentary is itself a constructed artifact, a manufactured structure whose production requires the same forward-looking cognition that tool manufacture requires. The orangutan that bends branches inward toward a central point is producing a structural form that does not exist in nature, and that will exist tomorrow morning in the same form it exists in tonight. She is building something. The cognitive distance between building a sleeping platform and building a tool for future use is shorter than it might appear. Let that thought drift rather than hold it tightly. Let the image of the platform in the canopy, in the dark with the orangutan settled into it, be something the mind rests on rather than analyzes. The social life of the orangutan is the least social of any great ape, and this distinction is not merely quantitative, it is qualitative. The chimpanzee and the gorilla live in groups whose social dynamics are the primary organizing principle of their daily lives. The bonobo lives in communities of rich social complexity, whose maintenance occupies a significant proportion of the daily activity budget. The orangutan, by contrast, is predominantly solitary. Adult females range alone with their dependent young. Adult males, outside the brief periods of mating encounters, are typically encountered alone. The social world of the orangutan is not the communal world of the other great apes. It is a world of long solitudes, occasional encounters, and relationships that persist across years despite the infrequency of the contact that maintains them. The research on orangutan social behavior has found that the solitary life is not simply imposed by the ecological conditions of the rainforest. The dispersed distribution of the fruit resources that the orangutan depends on, which makes large group living energetically costly because groups must travel farther than individuals to find sufficient food. It is also a social preference that the orangutan's behavioral system appears to sustain independently of the immediate resource context. Orangutans in areas of sufficient food density to permit grouping do not form the stable groups that the chimpanzee forms under equivalent conditions. The solitude is, in some sense, chosen as well as required. This does not mean the orangutan lacks social bonds. The mother-infant relationship in the orangutan is the longest and the most intensive of any non-human mammal. The nursing period extends to 7 or 8 years, longer than the nursing period of any other mammal documented by the research, including the other great apes. During this period, the infant is in continuous contact with the mother, clinging to her body during travel and sleeping pressed against her at night. The infant is not a passive recipient of this care. It is an active learner, watching everything the mother does, every food choice, every tool use, every route decision, every response to threat, and building from observation the knowledge base that its eventual independence will require. The knowledge transfer that occurs during the orangutan's long period of maternal dependence is the mechanism through which the cultural traditions of orangutan populations are transmitted across generations. The research on orangutan behavior across multiple field sites has found that the populations at different locations differ in the tool techniques, the food processing behaviors, and the social customs that they practice, in ways that reflect the local learning that the long maternal apprenticeship produces, rather than the genetic differences between the populations. Orangutans in Sumatra use tools to extract seeds from the nesia fruit, whose spiny husk the tool allows them to open safely. Orangutans in Borneo, which has no nesia, have no equivalent tool tradition. The tool use is cultural, transmitted by observation and practice within the social group, and the maternal apprenticeship is the transmission mechanism. The flanged adult male orangutan is one of the most distinctive animals in the world's forests, and his appearance is the product of a developmental biology that has no parallel in the other great apes. Male orangutans can develop in 2 ways. The majority develop normally through adolescence into unflanged adult males. Adults of full reproductive capacity, but without the prominent cheek flanges, the large throat pouch and the characteristic body size of the fully mature adult. These unflanged males mate and reproduce, but they do not have the social status of the flanged male and do not produce the long call. A minority of males develop the flanges, large fatty pads of tissue that extend from the sides of the face, expanding the male's apparent head width dramatically and producing the facial appearance that is one of the most recognizable of any primate. The development of the flanges requires a sustained hormonal state that the unflanged male does not maintain, and the transition from unflanged to flanged can be suppressed for years or even decades in the presence of a dominant flanged male whose social proximity suppresses the hormonal state required for the transition. The long call is the acoustic advertisement of the flanged male, a vocalizations that begins with a series of loud bubbling sounds and builds to the deep, resonant roar whose production the large throat pouch amplifies into a sound that carries several kilometers through the dense forest. The long call communicates the male's presence and his social status to the females and the other males within its range, functions as a territorial advertisement to competing males, and may serve as an honest signal of the male's quality to the females whose mating decisions the long call is partly designed to influence. The females who have heard the long call of a flanged male from several kilometers away, and who move toward rather than away from the source, are females whose mating decisions are guided by the acoustic information that the call carries about the male's size, health, and competitive status. The forest absorbs the long call and carries it through the understory in the low-frequency range that penetrates the dense vegetation most effectively. The female in her nest hears it. The unflanged male at the edge of the range hears it and moves away. The forest takes the sound and distributes it, and the sound contains everything that needs to be communicated without the visual contact that the forest's density prevents. Let that image of the sound moving through the forest in the dark be a restful one. The information carried through the trees, finding its recipients without urgency, doing what it needs to do at the pace that the forest allows. The fruit that the orangutan eats is the food whose distribution shapes the orangutan's entire ecology, its range size, its social system, its movement patterns, and the seasons of abundance and scarcity that define the quality of a year in the life of an animal that may live 60 years in the wild. The rainforests of Borneo and Sumatra produce their fruit in pulses. The mast fruiting events that occur irregularly every 2 to 10 years, when the majority of the forest's tree species fruit simultaneously in a burst of production that swamps the consumption capacity of the animals that depend on it. In the months of the mast fruiting, the forest is full of fruit, and the orangutan is full of the excess calories that the mast provides, storing the fat that the subsequent lean years will draw on. In the years between the mast events, the forest offers a sparse and variable fruit supply that requires the orangutan to range widely to know the locations of the fruit trees whose seasonal schedules are staggered enough to maintain some fruit availability across the year, and to supplement the fruit diet with leaves, bark, insects, and in some populations with honey from the wild bee colonies, whose nests the orangutan finds by following the bees or by memory of the nest locations that previous years have provided. The cognitive demands of this foraging ecology are the cognitive demands of a food memory problem at the scale of a forest. An adult orangutan's home range in Borneo covers between 500 and 2,000 hectares, an area of 5 to 20 square kilometers of dense rainforest, whose fruit tree distribution the orangutan maps and tracks across years of ranging. The mental map that sustains this tracking is a spatial memory, whose accuracy the field research has documented through the observation of the non-random movement patterns that the orangutans show when moving toward productive trees. Direct, efficient movements toward the trees that are currently fruiting, across terrain that does not allow the animal to see the destination from the starting point, in paths that the GPS tracking has found to be more direct than random search would produce. The orangutan is navigating by memory through a forest it cannot see across, toward trees it cannot see, that it knows are producing fruit because they were producing fruit in previous years at this season, or because the environmental signals of the current season match the signals of previous years when those trees produced. The memory is not simply a list of locations. It is a temporal map, a record of when as well as where, that allows the movement to be timed as well as directed. Let that quality of memory and navigation be something to hold briefly before releasing it. The orangutan moves through the forest at night in the seasonal dark, knowing where the fruit is not by sight, but by the accumulated knowledge of 30 years of seasons in the same forest. The forest knows her in the same way. She is part of the pattern of the place, as consistent and as predictable as the fruiting seasons themselves. The conservation situation of the orangutan is one of the most urgent in the great ape world. Both species, the Bornean orangutan and the Sumatran orangutan, which were recognized as separate species by the research in the 1990s, with the Tapanuli orangutan of northern Sumatra added as a third species in 2017, are critically endangered. The Sumatran orangutan's population is estimated at fewer than 14,000 individuals. The Tapanuli orangutan, the most recently described great ape species in the world, has a population estimated at fewer than 800 individuals, making it the rarest great ape on Earth by population size. The driver of the decline is deforestation, and the primary driver of the deforestation is the palm oil industry. The oil palm plantation has replaced hundreds of thousands of square kilometers of lowland Bornean and Sumatran rainforest since the 1970s, in a conversion whose rate has exceeded the capacity of the orangutan's slow reproductive biology, with its 7 to 8 year nursing period and its corresponding interbirth interval, to maintain the populations through reproduction. An orangutan female produces at most 5 to 8 offspring across a 50-year reproductive lifespan. A species that reproduces at this rate cannot sustain its population against the habitat loss rate that the palm oil expansion has produced. The research on the timeline of the orangutan's decline, if the current rate of habitat loss continues without mitigation, projects the extinction of the Sumatran orangutan within 2 to 3 decades in the wild. The Tapanuli orangutan, with its population of fewer than 800 confined to a single forest fragment in northern Sumatra, faces a more immediate trajectory. The conservation programs working to halt the decline, the habitat protection initiatives, the rehabilitation and release programs for orphaned orangutans, the sustainable palm oil certification schemes that attempt to create economic incentives for the protection of remaining forest, are working against a rate of loss that the resources available to the conservation community have not yet been sufficient to fully arrest. The platform in the canopy holds the orangutan through the night. The forest around her is one of the oldest and most complex ecosystems on Earth. The rainforests of Sunderland, the geological region that Borneo and Sumatra are part of, have been continuously forested for over 150 million years, accumulating a biodiversity whose depth reflects that continuity. The orangutan that sleeps in the canopy of this forest is an animal that has been in this forest in this form for at least 500,000 years. The forest knows her species in the way that old places know the things that have always been part of them. Let that oldness be the quality you rest in as this hour becomes the quiet that the middle of the night produces. The forest is 150 million years old. The orangutan is 500,000 years old in her present form. The night that holds them both is older than either. The leaves are still. The canopy has settled into the dark. The sleeping platform holds the orangutan's weight, as it has held it every night of her life. The bent branches springing slightly with each breath she takes. She breathes in. She breathes out. The forest breathes with her, in the slow exchange of gases that the millions of living things in it are conducting simultaneously, in the dark, without attention or effort. Let your own breathing join that exchange, in and out, without management, without direction, in the way that the body has always known how to do and that the night makes easiest. The orangutan is asleep in the canopy. The forest holds her. The night holds the forest. Let it hold you too, in the same unhurried dark, for as long as the rest continues. Sleep. The rain falls on the rainforest in a different way than rain falls anywhere else on Earth. The canopy intercepts the falling water and breaks it into the fine mist and the channeled streams, and the dripping that reaches the forest floor, not as individual drops, but as a distributed dispersal of the water that fell on the leaves above. The sound of rain in a rainforest is the sound of water being slowed and redirected, a complex, layered sound whose components range from the first impact on the upper canopy to the drips from the saturated lower canopy to the rivulets running down the trunks to the distant rushing of the streams that are receiving all of this water simultaneously. In this rain, the orangutan does not move if she can avoid it. The leaf umbrella that the research has documented in multiple orangutan populations is the behavioral adaptation to the rain, whose execution requires the presence of a large leaf within reach, and the cognitive connection between the rain, the discomfort of the rain, the leaf, and the concept of the leaf as a barrier between the rain and the body. The behavior is not instinctive. Young orangutans learn it by watching adults. The learning takes time, and the young orangutan that has not yet learned to use a leaf umbrella sits in the rain looking wet and unhappy, while the adult beside it holds a leaf over its head, in the most visually eloquent illustration available of what the cognitive gap between observer and practitioner looks like in the great apes. The night sounds of the Bornean rainforest are the sounds of a biological community that has been operating continuously in the same forest for millions of years, and the density and the variety of those sounds reflect the density and the variety of the life that produces them. The cicadas that begin at dusk continue through the night in a chorus whose individual components are inaudible against the collective sound, but whose collective sound is one of the defining acoustic qualities of the tropical rainforest at night. The frogs of the waterways and the damp ground layer add their calls to the cicada chorus. The sharp barks of the horned frog, the trilling of the tree frogs that have climbed to the canopy, the deep resonance of the river frogs in the streams below. The flying squirrels glide between the trees in the darkness, the wing membranes cutting the air in a sound the human ear can barely detect. The slow loris, whose eyes glow orange in the beam of a researcher's headlamp, moves through the lower canopy in the deliberate, measured pace of a predator that is not in a hurry. In this acoustic world, the orangutan sleeps with the selective attention of an animal that has learned which sounds belong to the night and which sounds require waking. The hornbill's call at 3 a.m. is not a signal to wake. It is part of the forest's normal, nocturnal acoustic palette. The crack of a large branch below the platform is a signal to wake. It might be a sun bear or a clouded leopard investigating the base of the tree. The orangutan's sleeping brain is not fully off. It is in the state of reduced but maintained awareness that the forest requires of everything that sleeps in it. The relationship between the orangutan and the fig tree is one of the most important ecological relationships in the forests of Borneo and Sumatra, and its importance reflects the fig tree's unusual strategy for producing fruit in the irregular, non-seasonal pattern that the orangutan depends on for its caloric supply in the years between the mast fruiting events. The fig trees of the tropical rainforest produce fruit asynchronously. Different individual trees fruiting at different times, with no synchrony between individuals of the same species, in a pattern that ensures that there are always some fig trees producing somewhere in the forest at any time of year. This continuous, scattered availability of figs is the food resource that sustains the orangutan through the lean periods between the mast fruiting events, and the orangutan's knowledge of the fig tree locations within its home range is one of the most carefully maintained components of its spatial memory. The research on orangutan movement in relation to fig tree fruiting has found that orangutans visit producing fig trees within their range at frequencies that exceed chance, consistent with the active monitoring of fig tree fruiting status across the home range rather than the passive encounter of fruiting trees during normal ranging. The orangutan is simultaneously the beneficiary of the fig tree's fruit and the agent of the fig tree's seed dispersal. The seeds that pass through the orangutan's digestive tract and are deposited in the dung across the ranging area of the individual contribute to the fig tree's reproduction at distances that the tree cannot achieve through any other dispersal mechanism in the dense forest. The fig tree feeds the orangutan spreads the fig tree's seeds. The relationship has been ongoing for longer than the orangutan's current species has existed. The orangutan mother's response to the death of an infant is one of the most distressing behaviors documented in the primate literature, and the research on it has contributed to the evolving understanding of grief and emotional experience in non-human animals. When an infant orangutan dies, the mother may carry the body for days or weeks before releasing it. She grooms the body. She attempts to nurse it. She protects it from other animals and from the researchers who would otherwise be able to collect it for the scientific analysis that would determine the cause of death. The behavior has been interpreted by the researchers who have observed it as the behavioral expression of an attachment bond, whose disruption the mother's emotional system has not been able to resolve through the normal termination of contact that the living infant's growing independence would eventually produce. The research on grief in non-human primates has found equivalent behaviors in chimpanzees, gorillas, and baboons, the carrying of dead infants by mothers, the apparent distress responses to the deaths of close social partners, the reduced activity and the reduced food intake in the period following the death of an individual with whom a close bond existed. Whether these behaviors represent an experience of grief in any subjective sense, whether there is anything it is like to be an orangutan mother carrying her dead infant through the forest canopy, is a question that the behavioral evidence cannot resolve. The behavioral evidence is unambiguous. The bond is real. Its disruption produces a profound behavioral response, and the response has a quality that the vocabulary of grief, however imprecise its application to non-human animals may be, is more accurate than any alternative. The hands of the orangutan are the most human-like hands in the non-human animal world after those of the gorilla, the chimpanzee, and the bonobo, and their structure reflects the evolutionary history that the great apes share with the human lineage. The precision grip, the ability to hold small objects between the thumb and the index finger in the way that the human hand holds a pen, is present in the orangutan's hand, in a form that the research on great ape manual dexterity has found to be as refined as the humans in most respects. Though the proportions of the thumb relative to the fingers differ in ways that reflect the orangutan's primarily brachiating locomotion rather than the ground-based manual manipulation that human tool use typically involves. The orangutan that is using a stick to extract insects from a tree hole is using a precision grip, calibrated to the diameter of the stick and the force required to probe the hole without breaking the tool. The adjustment of the grip as the stick encounters resistance, the repositioning of the fingers to increase the force without losing the accuracy of the probe direction, is a hand skill whose neural basis in the corticospinal pathways that control fine motor movement is the same pathway that controls the human hand's fine motor skills. The hand is doing what hands were always for. The orangutan has been doing what hands are for in the canopy of a rainforest for 500,000 years. The Tapanuli orangutan, described as a new species in 2017, inhabits the Batang Toru forest of northern Sumatra in a population whose isolation from the Sumatran orangutan to the north has been maintained for approximately 10,000 years since the last period of forest connectivity between the two populations. In those 10,000 years, sufficient genetic and morphological divergence has accumulated to meet the species-level criteria that the research used to recognize the Tapanuli as a third species, a relatively short time for speciation in the primate world, reflecting the small population sizes and the geographic isolation that accelerate genetic drift in the manner that evolutionary theory predicts. The forest that the Tapanuli orangutan inhabits is scheduled to be partially flooded by a hydroelectric dam project whose construction began in the years after the species was described. The intersection of a new species description and a major infrastructure project whose implementation would destroy habitat, supporting a population of fewer than 800 individuals of that species, is one of the most starkly drawn examples available of the conservation challenge that the economic development of the tropical developing world presents for the biodiversity it contains. The Tapanuli orangutan's existence was unknown to science until 2017. By 2030, it may be functionally extinct in the wild. The night is deep in the forest now. The rain has stopped. The dripping from the saturated leaves is the only water sound remaining, and it is softer than the rain, a diminuendo, a gradual quieting of the water's presence in the soundscape as the leaves give up what they held. The orangutan in her sleeping platform has shifted position once in the night. The way that the sleeping body shifts position to redistribute pressure across the contact surfaces and maintain the circulation in the compressed tissues. The shift was brief and smooth, the unconscious adjustment of a body that has been sleeping in this posture on this surface for 30 years and whose nervous system manages the transitions between positions without waking the awareness that oversees the day. You have shifted position tonight, or you will. The body knows when to move and moves without instruction. Trust that. The body managing its own sleep is the body doing exactly what it was designed to do, without the management of the awareness that is, right now, softening at the edges. Let the edges soften further. The forest is very quiet. The dripping of the leaves has almost stopped. The moon has cleared the canopy, and the platform where the orangutan rests is in a patch of moonlight that makes her red-brown fur look silver, in the way that moonlight makes all colors look silver in the deep of the night. She breathes. You breathe. The forest breathes. The whole of this night is a single breath, in and out, slow and unhurried, moving through the canopy and the forest floor and the sleeping bodies of everything that has found its place in the dark, and let the dark hold it. You have found your place. Let the dark hold you. Sleep. The play behavior of the young orangutan is one of the most endearing and most informative windows into the cognitive development of a species that will eventually be among the most intelligent animals on Earth. The infant that hangs from its mother's arm and swings itself in a small arc, testing the physics of pendulum motion with its own body. The juvenile that dismantles a termite nest with systematic exploratory behavior, picking apart the structure to find the chambers and the insects inside. The subadult that repeatedly uses a stick to probe a hole and then examines the stick's tip for what has adhered to it. These are play behaviors whose cognitive content is the cognitive content of the adult behaviors they prefigure, practiced in the context of the mother's proximity and the safety she provides. The learning that the long orangutan childhood facilitates is not only the behavioral skills that the play is practicing, it is the general capacity for the problem-solving approach, the try, assess, modify, try again approach, whose application across novel problems is what the adult orangutan's flexibility in the face of new challenges reflects. The play builds not a repertoire but a method, one that allows the adult to approach unfamiliar food, novel obstacles, unencountered situations with the investigative curiosity that the research has found to be one of the most consistent behavioral signatures of the orangutan's cognitive style. The fruit bats that emerge at dusk from the cave roosts on the slopes of the limestone hills at the edge of the lowland rainforest are part of the ecological community that the orangutan's forest sustains, a species whose flight patterns in the evening light are one of the most visible indicators of the diversity that the intact tropical forest holds. Millions of bats emerging in the spiral column that the thermals above the cave entrance produce, moving outward into the forest canopy in the tens of millions, to forage on the same fruit trees that the orangutan is also using, and whose seed dispersal service the bat provides at night in the same way that the orangutan provides it during the day. The ecological web of the tropical rainforest is a web of such interdependencies. The tree depends on the bat for seed dispersal, and on the orangutan for seed dispersal, and on the hornbill for seed dispersal, and on the sun bear for seed dispersal. And all of these dispersers depend on the tree for the food the fruit provides. And the whole community depends on the rainfall and the soil and the fungi that connect the tree roots, and the insects that process the dead wood, and the microorganisms that cycle the nutrients from the dead leaves back into the forms that the tree's roots can absorb. The orangutan is in the middle of this web, connected to it at dozens of points, sustained by it and sustaining it in the way that the long-resident species of an ancient forest always is. The vocalizations of the orangutan include not only the long call of the flanged male, but a repertoire of softer, closer-range sounds that the mother uses with her infant, that juveniles exchange in play, and that adults produce in the contexts of mild threat, mild invitation, and the social greetings that occur when individuals who know each other encounter each other in the forest. The kiss squeak, a sound produced by kissing the back of the hand or the lips while drawing in air, is the most common vocalization in the orangutan's repertoire and functions as an alarm call that communicates the presence of a threat without specifying its nature or direction. The grumph, a short, low exhalation, is used in contexts of mild annoyance or the assertion of priority at a food source. The long call sequence, whose full production takes several minutes, and whose component sounds carry information about the male's identity, his direction of movement and his competitive status, is the acoustic output of the most information-rich vocal behavior in the orangutan's repertoire, and its reception by the forest's other orangutans produces behavioral responses that the research has documented in enough detail to characterize the information content that the call carries. The forest at night holds the memory of the day's long calls in the way that all sounds leave their traces in the environment. The echoes that bounced off the trees have long since decayed. The vibrations in the leaves have settled, but the animals that heard the call and adjusted their behavior in response to it carry the behavioral consequence of the information in their positions, their trajectories, and their states of alertness or relaxation as the night began. The communication of the day has shaped the night's arrangements. The forest remembers the calls through the behavior of the animals whose choices the calls informed. The orangutan's lifespan in the wild is estimated at 35 to 45 years for females, somewhat less for males, due to the higher mortality risks of the more competitive male life. In managed care, individuals have lived into their 50s. Across this lifespan, the female orangutan may raise 5 to 8 offspring, investing 7 to 8 years in each, building across the decades the accumulated knowledge of the forest that makes the old female the most ecologically sophisticated individual in her home range. The old female orangutan, the one who has been in the same forest for 4 decades, who has raised offspring and watched them disperse and occasionally encountered them again in the forest as adults with offspring of their own, carries in her behavioral system the most complete picture of the forest's temporal dynamics that any individual in the system possesses. She knows which trees produce in which seasons of drought and flood. She knows the unusual fruiting events whose recurrence she has witnessed 2 or 3 times in her life. She knows the parts of the forest where the water pools in the dry season and the parts where it drains fastest. This knowledge cannot be measured. It can only be inferred from the behavioral decisions that it produces. The route choices, the timing of movement, the food source selections, and the research on orangutan movement ecology has found the movement patterns of older females to be substantially more efficient than the movement patterns of younger animals at comparable points in the seasonal cycle. The wisdom is not a metaphor. It is an empirically demonstrable property of the aged individual whose behavioral decisions reflect the accumulated information of decades of ranging in the same forest. The forest is a better place for having her in it. The other orangutans that share her range, however infrequently they encounter her, benefit indirectly from her presence. The trails she maintains through the canopy, the food trees she tends toward, and whose productivity her use documents, the spatial patterns her ranging produces that other animals can read as information about the forest's state. The canopy is still. The moon has moved to the west, and its light falls now on the far side of the tree where the sleeping platform is, leaving the platform in shadow. The orangutan has not moved since the early part of the night. Her breathing is slow and regular, the tidal breathing of deep sleep, the chest rising and falling in the rhythm that the body sustains without any supervision from the awareness that has gone wherever awareness goes when it is no longer needed. The forest does not notice this. The forest has been holding sleeping animals in its canopy for hundreds of millions of years and has developed no relationship with the awareness or the absence of awareness of the things it holds. The branches are indifferent. The night air is indifferent. The moonlight that now illuminates the western face of the tree and leaves the platform in shadow is indifferent. What the forest provides is the physical fact of its presence, the branches that hold the platform, the air that carries the breath away, the darkness that covers everything equally, the sounds that are what they are and mean what they mean to those who are awake enough to hear them. You are less awake than you were when this began. The sounds around you are what they are. The dark is what it is. The breathing is what it is, and it is continuing on its own, as it has always continued, as it will continue, through the night and into the morning that is somewhere on the other side of the sleep that is arriving now. Let it arrive. The orangutan is in the canopy. The forest holds the canopy. The night holds the forest. and the breathing holds everything else. The proboscis monkey that shares the Bornean forest with the orangutan is one of the forest's most visually distinctive residents. The adult male's large, pendulous nose, whose function in amplifying the vocalizations the male produces, has been studied and found to increase the resonance and the carrying power of the nasal honks that the male uses in social contexts, is as dramatic an example of sexual selection in the mammalian world as the peacock's tail or the elk's antler. The proboscis monkey lives in mixed groups in the coastal mangroves and the riverine forests that border the orangutan's inland range, and its presence in the forest is audible before it is visible. The male's alarm call, a loud, resonant honk, carries through the mangrove canopy, in a way that the forest's other residents read as information about the presence of predators or disturbance in the area the proboscis monkey inhabits. The orangutan that hears the proboscis monkey's alarm call incorporates the information into its own assessment of the forest's current risk level in the way that the research on cross-species alarm call recognition has found to be common across the animal communities of complex ecosystems. The forest's animals are listening to each other, reading each other's behavioral states, and adjusting their own behavior accordingly in a continuous exchange of information that the ecological concept of the alarm call cascade describes. The orangutan is embedded in this cascade, receiving information from the birds, the monkeys, and the small mammals whose alarm calls it has learned to read across decades of life in the same forest. The dawn is still hours away. The forest's nocturnal sounds have settled into the quieter register of the deep night. The cicadas have modulated to a lower frequency. The frogs have found their calling intervals. The occasional distant crash of something large moving through the understory has subsided. The orangutan on her platform has been asleep for hours. The sleep of the great apes has been studied in managed care with the sleep monitoring technology whose application to wild populations remains technically challenging. And what the research has found is that the great ape's sleep architecture shares many features with human sleep. The alternation of slow-wave sleep with REM sleep, the cycling through these stages across the night, the differential functions of the two sleep states in memory consolidation and neural maintenance. The orangutan that spent the day solving food problems, navigating the spatial complexity of the forest's fruit distribution, and managing the few social encounters that her largely solitary life produces, has done the cognitive work whose consolidation the night's sleep is now completing. The memories of the day, the location of the fig tree whose fruit was ripe, the branch root that avoided the exposed gap in the canopy where the hawk eagle had been perching, the texture of the bark that the termites had been working beneath, are being integrated into the long-term memory that the slow-wave sleep facilitates, and the emotional residue of the encounters that produced arousal is being processed in the REM sleep, whose function in emotional regulation the research has found to be as important as its function in memory consolidation. The orangutan is not just resting. She is doing the cognitive work of being an orangutan while her body is still. The sleep is part of the intelligence, not the absence of it. Let that be the last thought before the thinking stops. The sleep is part of the intelligence. What the body does while the mind is quiet is part of what the mind needs to do. The orangutan understood this before understanding was a word. She builds her platform. She settles into it. She releases the awareness of the day into the darkness that the forest provides every night, and the rest does what it does. The consolidation, the maintenance, the preparation for the day that is 12 hours away. You are doing the same thing now. The consolidation is proceeding without your management of it. The maintenance is proceeding without your awareness of it. The preparation for tomorrow is proceeding in the same dark and the same quiet that the orangutan's preparation is proceeding in the rainforest of Borneo, 200 feet above the ground, on a platform of bent branches that she built in 5 minutes from the accumulated knowledge of 30 years. The forest holds her. The night holds you. The breathing holds everything else. There is nothing more required. Let it be enough. It is. The sun bear, which shares the Bornean forest with the orangutan, shares the smallest of the world's 8 bear species, and the one whose existence most people have never encountered in any context. It weighs between 27 and 80 kilograms, carries a cream-colored chest patch on its otherwise black fur, and is equipped with the longest tongue relative to body size of any bear, a tongue adapted for extracting honey from wild bee nests, insects from tree holes, and the soft hearts of palm fronds from beneath their protective outer layers. The sun bear and the orangutan encounter each other occasionally in the forest, and the encounters are typically brief negotiations over access to a shared food source, a bee nest, a fruiting tree, that the sun bear's greater willingness to be aggressive and the orangutan's greater willingness to simply leave usually resolve without prolonged conflict. The sun bear's relationship with the trees of the Bornean forest has its own ecological dimension that the research has recently begun to characterize. The sun bear tears apart dead and dying trees in its search for insects, creating openings in the forest structure that allow light to reach the understory and that create the conditions for the regeneration of the understory plants whose growth fills the light gap. The sun bear is a forest engineer in the same way that the woodpecker is a forest engineer in the temperate forests of the north, a species whose foraging behavior creates habitat for other species as a byproduct of meeting its own caloric needs. The orangutan that shelters in the cavity that a sun bear's excavation has opened in a tree trunk is benefiting from the bear's foraging in a relationship that neither animal has designed, but that the forest has been sustaining for as long as both species have been present in it. The peat swamp forests of Borneo and Sumatra are among the most carbon-dense ecosystems on Earth, and the orangutan's presence in them is part of what makes them among the most biologically important. The peat that accumulates in the waterlogged soils of the swamp forest stores carbon at densities that exceed the carbon storage of most other terrestrial ecosystems. The peat of the Bornean lowlands, in some areas dozens of meters deep, represents centuries of accumulated organic matter that the waterlogged, oxygen-depleted conditions of the swamp have prevented from decomposing. This carbon remains in the peat as long as the forest above it remains intact and the water table of the swamp remains high. When the peat swamp is drained for agriculture, which is the first step in the conversion of peat swamp to oil palm plantation, the carbon that has been accumulating for centuries is exposed to the oxygen that the drainage allows, and the microbial decomposition that the oxygen enables releases the stored carbon as carbon dioxide at rates that make the converted peat swamp one of the most significant point sources of greenhouse gas emissions on the planet per unit of area. The burning of the exposed peat, which produces the smoke events whose visibility from space has been documented in satellite imagery and whose health consequences for the human populations of equatorial Southeast Asia have been studied and found to be severe, adds to the atmospheric carbon release the combustion products of the organic matter that the fire consumes. The conservation of the orangutan is therefore also the conservation of one of the world's most important carbon stores. The forest that holds the orangutan is the forest that holds the carbon. They cannot be separated. The research station at which the most intensive study of wild orangutan behavior has been conducted, the Cabang Panti Research Station in the Gunung Palung National Park in Borneo, operational since 1985, has produced a dataset on orangutan behavior whose temporal depth is now approaching 4 decades of continuous observation of a known population of individually identified animals. The researchers who began the study in the 1980s have watched the infants of that era grow into adults. The adults age into elders, and the elders die and be replaced by the generation whose births the research documented. The longitudinal depth of this dataset is what makes it the most informative source available on the individual life histories of wild orangutans, because the behavioral ecology questions that matter most for conservation, the reproductive rates, the juvenile mortality rates, the effects of habitat quality on individual body condition, and reproductive success, are questions that can only be answered with data spanning the full reproductive lifespan of the individuals being studied. The researcher who spent 30 years watching the same orangutans is watching something that changes slowly enough that the change is only visible across the full span of the observation. The forest changes. The climate changes. The human pressures on the boundary of the national park change, and the orangutans, whose own lifespans span the same decades that the research program has been running, change with it. their behavioral adjustments to the changing conditions, producing the data that documents what the changing forest means for the species that has been living in it since long before any research program arrived to watch. The last sound of the night in the Bornean forest is often the first sound of the morning, the gibbons that begin calling before the light is strong enough to see by, whose duets carry through the canopy in the pre-dawn in a sound that the field researchers who have spent years in the forest describe as the most beautiful regular sound in the natural world. The Siamang gibbon, the largest of the gibbon species and the one whose throat sac amplifies its calls to the greatest volume, begins with the female's series of rising bars and builds through the male's contributions to the climactic great call that carries through a kilometer of dense forest without apparent diminishment. The orangutan hears this. The hearing of the great apes is broadly similar to human hearing in its frequency range and its sensitivity, and the gibbon's call is well within the range that the orangutan's auditory system processes with the same clarity that the field researchers process it. Whether the orangutan experiences anything in response to the gibbon call, whether the sound produces in the orangutan's auditory cortex any state that resembles what the human researcher describes when they use the word beautiful, is a question that the comparative neuroscience has not resolved and may not resolve in a form that the language available to describe it can fully capture. What the orangutan does in response to the gibbon's dawn call is what the observation has documented. She opens her eyes. She lies in the platform for a few minutes longer, the way that a slow waker lies in the dark for a few minutes after the sound that ends the sleep, in the transition between the sleep and the day that both the gibbon and the orangutan know is beginning. Then she rises. She tests the platform's edge with one foot. She reaches for the first branch of the day. The forest receives her, as it has always received her, into the green and the light and the slow-moving life of another day in the oldest forest in Southeast Asia. You are still in your rest. The gibbon has not called here. The morning is not yet present. There is time. Let the orangutan take the first branch of her day while you take the rest of your night. She has been doing this for 30 years and knows the way through the canopy without your help. The forest will hold her. The day will hold the forest. The night is still holding you. Stay in it a little longer. Let the breath carry you through. Let the breath come in slowly. Let it go. There is a forest in the Democratic Republic of Congo, south of the Congo River, where a species of great ape lives that most people have never seen and that science did not formally recognize as separate from the chimpanzee until 1929. The forest is dense and wet and ancient, part of the Congo Basin rainforest, the second largest tropical forest on Earth, and in it, in the canopy and on the ground, and in the waterways between the forest fragments, the bonobo lives in communities whose social life is unlike anything else in the great ape world. The bonobo looks like a slender chimpanzee. It has the same basic body plan, the same opposable thumbs, the same large brain relative to body size, the same capacity for the tool use and the social complexity and the learning that the great apes share. But the bonobo is not a chimpanzee. It separated from the chimpanzee lineage approximately 2 million years ago, when the Congo River formed and created a geographic barrier that the ancestral population on one side of the river could not cross, and the two populations that resulted evolved independently in the ecosystems on their respective sides of the river. The chimpanzee evolved north of the Congo, the bonobo evolved south of it. 2 million years of separate evolution in different ecological contexts produced two animals whose external similarity conceals an internal difference in social organization, in temperament, in the mechanisms they have developed for managing conflict. That is one of the most important contrasts in the primate world. Let that idea settle into the quiet of the evening. Two rivers, two forests, two answers to the same evolutionary starting point. Subscribe right now and help us reach 1,000 subscribers. Hit that button. It costs you nothing and it keeps this channel going. Drop a comment telling us where in the world you are watching from and what time it is. We read every single one. The bonobo community is organized around the adult females in a way that the chimpanzee community is not. In the chimpanzee, the adult males form the competitive core of the community, the hierarchy whose positions determine reproductive access. the territorial patrols whose outcomes determine the community's range, and the coalitions whose political dynamics shape the daily social life of every individual. The adult females in the chimpanzee community are peripheral to this male-dominated structure, forming their own hierarchies but without the same degree of collective influence on the community's overall social dynamics. In the bonobo, the adult females form coalitions that collectively outrank the adult males and that enforce a social order in which male aggression toward females is suppressed by the coordinated response of the female group to any male that initiates it. A bonobo male who attacks a female may find himself facing not just the attacked female, but several of her female allies, a coalition whose collective size and whose collective motivation, backed by the social bonds that the females have formed through years of affiliative interaction, is sufficient to displace the male from any position he has tried to assert through aggression. The male learns, across the years of his development in the bonobo community, that aggression toward females produces a social cost that makes the strategy unprofitable. The social system selects against male aggression toward females by making it consistently unsuccessful. The female's social power in the bonobo community is not simply the power of coalition size, it is the power of access to the community's social resources, the grooming relationships, the food sharing, the affiliative sexual contacts that the female controls and that the male depends on for his own social well-being. The male bonobo, whose relationships with the adult females are good, is a male who eats more reliably, who is groomed more frequently, and who participates more fully in the community's social life. The male whose relationships with the females are poor, whether through aggression or through social inattentiveness, is a male who is excluded from these resources in ways that the research on bonobo social dynamics has found to have measurable effects on his body condition and his reproductive success. The mother's role in the male's social career extends beyond the nursing period that the bonobo shares with the other great apes. The research on bonobo social behavior has found that the adult male's social status within the community correlates with his mother's social status, and that the mother actively intervenes in the son's social conflicts in ways that support his position and that the son's rivals must account for. The adult male bonobo, whose mother is a high-ranking female in the community's female hierarchy, has a social resource whose value the research has quantified in the reproductive success that the son achieves. Males with high-ranking mothers reproduce more successfully than males with lower-ranking mothers, not through any direct genetic effect, but because the mother's social influence shapes the environment in which the son competes for reproductive opportunities. The mother and the adult son, traveling together, foraging together, grooming each other in the forest of the Congo Basin, is an image that the bonobo's social system produces and that the chimpanzee's social system does not. In the chimpanzee, adult sons and mothers may maintain contact, but the son's integration into the male competitive hierarchy and the mother's peripheral position within it tend to reduce the frequency and the intensity of the mother-son relationship as both age. In the bonobo, the mother's continued high status and the son's continued dependence on that status maintain the relationship into the son's full adulthood in a way that has no parallel among the other great apes. The affiliative behaviors that characterize the bonobo's social life are more varied and more frequent than the equivalent behaviors in the chimpanzee, and their frequency and their distribution across the community's social relationships give the bonobo community its distinctive social texture. Grooming, the mutual examination and cleaning of the fur that is the primary currency of social bonding in most primates, is common in the bonobo and occurs between all age and sex combinations. Adult females groom each other, adult males groom each other, females groom males and males groom females. Adults groom juveniles and juveniles groom adults. The grooming network of the bonobo community is dense and largely non-exclusive. It does not produce the preferential grooming relationships between coalition partners that the chimpanzee's male hierarchies produce. The bonobo's use of affiliative behavior to manage social tension is most visible in the context of food, the situation in which competition is most likely, and in which the management of that competition most clearly determines the social outcome. When bonobos encounter a concentrated food resource, The initial response is often the same kind of excitement and agitation that food competition produces in most social animals. But in the bonobo, this agitation is typically resolved not through the dominance displays and the aggressive exclusion that the chimpanzee uses to establish feeding priority, but through the affiliative behaviors that reduce tension between the individuals at the food site. The grooming, the physical contact, the food sharing that follows the initial excitement converts the competitive situation into the cooperative one that allows multiple individuals to feed at the same site without the escalation to aggression that the chimpanzee's equivalent situation typically produces. This social technology, the use of affiliation to manage tension before it escalates to aggression, is one of the most studied aspects of bonobo behavior. And what the research has found in it is not simply a behavioral repertoire for conflict management, but a social system whose design produces a fundamentally different kind of social life from the chimpanzees. The chimpanzee community is organized around the management of aggression after the fact, the post-conflict reconciliation that repairs the social damage that the aggression has produced. The bonobo community is organized around the prevention of aggression before it occurs, the affiliative behaviors that reduce the tension that would otherwise escalate. Both systems manage the same underlying problem of living in a group where individual interests conflict. They manage it at different points in the conflict timeline. The forest around the bonobo community at night is the forest that has held this species for 2 million years, and its sounds and its darkness are the sounds and the darkness that have been the backdrop of every night in the bonobo's evolutionary history. The insects of the Congo Basin rainforest produce a nighttime soundscape whose density and whose variety reflect the biological productivity of one of the most species-rich environments on Earth. The forest floor, which is waterlogged in the parts of the range where the Congo Basin's drainage has not yet cut the channels that remove the excess water, holds a community of frogs whose calls rise in the evening and continue through the night in the rhythmic patterns that each species' calling behavior produces. Let those sounds be something the mind rests against rather than something it tries to identify. The frog chorus in the Congo Basin rainforest, the insects in the canopy, the soft sounds of a community of bonobos in the trees above, settling into the sleeping positions that the night has found for each of them. The bonobo builds sleeping platforms in the same way that the orangutan does and the chimpanzee does, bending branches toward a central point, weaving them together into a structure stiff enough to hold the body's weight, lining the cup with softer material for cushioning. Each individual builds its own platform, typically at a height of 10 to 30 meters in the canopy, and the platforms of community members sleeping near each other on a given night may be close enough to allow the sounds of one individual's sleep to reach the others. The community sleeps together in the sense of sharing the same section of canopy on any given night, though not in the sense of sharing the same structure. The research on bonobo sleep behavior has found that the individuals who choose to sleep in proximity to each other on any given night are more likely to be individuals with strong social bonds than individuals chosen at random from the community. The sleeping arrangement reflects the social structure, with affiliative partners clustering in the canopy in the same way that they cluster during the day's social activities. The sleeping community is the day's community transposed into the night's horizontal. The bonobo's relationship to water is more intimate than the other great apes. Communities in some parts of the range regularly wade into rivers and streams to forage for aquatic plants and small aquatic animals, and the research on bonobo aquatic behavior has documented the wading behavior in enough detail to characterize it as a deliberate foraging strategy rather than an accidental encounter with water. The bonobo that wades chest-deep into a river to reach the floating vegetation on the far side is a bonobo using a resource that the chimpanzee, whose aversion to water immersion is well documented, does not typically exploit. The willingness to enter water is one of the bonobo's ecological advantages over the chimpanzee in the waterlogged environments of the Congo Basin's south bank. The Congo River itself is the boundary that separates the bonobo from the chimpanzee, and the research on great ape river crossing has found that neither species regularly crosses the Congo at its widest points. The river is too wide and too fast in the sections that form the effective boundary between the two species ranges, and the evolutionary divergence that the 2 million years of separation has produced makes any future crossing and subsequent hybridization increasingly unlikely, even if the physical boundary were crossed. The river that created the bonobo is the river that continues to define it. The geographic fact that initiated the species divergence remains the geographic fact that maintains the species separation. The face of the adult bonobo is darker than the chimpanzee's, typically black with pink lips, and the hair on the top of the head parts naturally in the middle in a way that gives the bonobo a distinctive appearance that the chimpanzee does not share. The body is more slender than the chimpanzee's, and the legs are proportionally longer, giving the bonobo a more upright posture when walking bipedally than the chimpanzee maintains. The bonobo walks bipedally more frequently than the chimpanzee does in the wild. Not as frequently as the human, but often enough that the bipedal posture is a regular component of the bonobo's locomotor repertoire, rather than an occasional performance. The vocalizations of the bonobo are higher pitched than the chimpanzees and include a range of calls whose acoustic properties the research has characterized in the communities studied at the Wamba and the Luikotale field sites in the Congo Basin. The most frequently produced call is a high-pitched peeping sound that functions as a contact call within the community and as a food call when a productive food source has been found, a signal that recruits community members to the food location in the way that the chimpanzee's pant hoot recruits community members to food sources. The research on bonobo food calls has found that the bonobos who produce the call are calling their social partners, their affiliative allies, the individuals with whom their grooming relationships are strongest, rather than signaling to the community at random. The food call is a social act as well as an informational one. The conservation situation of the bonobo mirrors the orangutans in its urgency and in the primary driver of the threat. The bonobo is found only in the Democratic Republic of Congo, in an area whose boundaries have been defined by the Congo River and its tributaries across the 2 million years of the species' existence. The estimated population of between 15,000 and 20,000 individuals is distributed across a range that is being reduced by the deforestation and the bushmeat hunting that the Congo Basin's human population growth and its economic development are producing. The bonobo is entirely dependent on the forest, entirely confined to the DRC, and entirely at the mercy of the political and economic conditions of a country whose stability has been chronically disrupted by the decades of conflict that have made the conservation management of its wildlife resources one of the most difficult challenges in the world. The research programs that work with bonobos in the wild operate in conditions that are logistically and sometimes physically challenging. The remoteness of the field sites, the difficulty of access, the disruption that political instability produces for the long-term presence that great ape behavioral research requires. The programs that have maintained continuity despite these challenges have produced the knowledge base whose synthesis this documentary draws on, and their continuation is the foundation of any informed conservation planning for a species whose behavior and ecology are still being characterized in significant dimensions. The forest is dark. The community is in the canopy, the sleeping platforms distributed through the trees in the spatial pattern that the day's social dynamics have produced. The adults with the strongest bonds are in the closest platforms. The juveniles are near their mothers. The adult males whose relationships with the adult females are strongest are in the center of the sleeping cluster. The males whose relationships are weakest are at the periphery. The social geography of the day has become the spatial geography of the night, and the night will hold it until the dawn calls the community back into the waking life whose management the day requires. You are in your own night. The social geography of your day has settled into whatever the dark holds of it, and the dark is not requiring you to manage it now. The relationships and the conflicts and the affiliations and the tensions of the day are where the day left them, and they will be where the day left them when the morning comes. What the night offers is the interval between the management of one day and the management of the next, and the body knows how to use this interval in the same way that the bonobo's body knows how to use the sleeping platform in the canopy, by releasing the management and letting the systems that sustain life do what they were built to do in the dark. The Congo Basin breathes in the dark. The bonobo breathes with it. You breathe with both of them, in the slow, unhurried rhythm of the body that has released the day and accepted the night and found in the acceptance the rest that has been waiting since the light went out. Let the forest hold you tonight. Let the breathing continue without your management of it. Let the dawn come when it comes. You are in the dark now, and the dark is enough, and the breathing is enough, and the rest that is arriving is the rest that the night was always going to bring you. Sleep. The cognitive capabilities of the bonobo have been studied intensively in both wild and managed populations, and the picture they produce is a picture of an animal whose intelligence is comparable to the chimpanzees across most of the dimensions that the comparative cognitive science has assessed, with differences in emphasis that reflect the different social systems of the two species. The bonobo's social intelligence, the ability to track complex social relationships, to read emotional states in others, and to use social information to guide behavioral decisions, has been found in several studies to exceed the chimpanzees on the tasks that specifically tax social cognition, consistent with the bonobo's more complex and more cooperative social environment, placing stronger selection pressure on the neural systems for social reasoning. The bonobo's performance on the theory of mind tasks that assess the ability to understand that others have mental states different from one's own has been studied in managed populations, and the results have found capabilities that the research characterizes as consistent with a theory of mind, at least partially equivalent to the chimpanzees, and possibly more developed in the social-emotional dimensions of theory of mind, whose relevance to the bonobo's affiliative social system is more direct than its relevance to the chimpanzee's competitive hierarchy. The bonobo in a managed care setting that observes a human experimenter place food under one of two cups and then leave the room before a second experimenter, who was not present during the hiding, enters and asks the bonobo to indicate where the food is. This task, which requires the bonobo to understand that the second experimenter does not know what the first experimenter did, is performed by bonobos at above chance rates in the research designs that have been able to control for the simpler behavioral cues that the subjects might otherwise be using. The bonobo understands at some level what others know and do not know. The empathy research on bonobos has produced some of the most discussed findings in the comparative social neuroscience of the great apes, because the behavioral evidence for empathic responding, the adjustment of one's own behavior in response to the emotional states of others, is more extensive and more consistent in bonobos than in chimpanzees, in ways that the two species' different social systems would predict. The consolation behavior, the unsolicited approach and physical contact with a distressed individual whose distress was produced by an interaction not involving the approaching individual, is well documented in bonobos and relatively rare in chimpanzees. The bonobo that approaches a community member who has been involved in a conflict and not been reconciled, and offers a hug or a grooming contact without any apparent social motivation beyond the reduction of the other's distress, is doing something that the chimpanzee rarely does in the same context. The research interpretation is that the bonobo's higher baseline empathic responding reflects the social selection pressure of an affiliative social system in which the maintenance of good social relationships across the community requires attending to and responding to the emotional states of others, a demand that the chimpanzee's more competitive and hierarchical social system does not place on its members to the same degree. The yawn contagion research. The finding that yawning in one individual triggers yawning in others who observe it, a phenomenon whose mechanism in humans involves the neural systems associated with empathy, has found that bonobos show yawn contagion toward family members and toward individuals with whom they have strong social bonds, but not toward strangers. The contagion is socially selective. It occurs in the context of the social bonds that the affiliative system has built, and its selectivity reveals the social mapping that underlies the empathic response. The forest of the Congo Basin is the forest that has held the bonobo in evolutionary isolation for 2 million years, and the quality of its oldness is a quality that the body can rest in tonight. The Congo Basin rainforest began forming in its current configuration approximately 34 million years ago, when the continental drift of the African plate and the changes in global climate that the Eocene-Oligocene transition produced created the climatic conditions that the tropical rainforest requires. The forest has expanded and contracted across the climate cycles of the intervening millions of years, shrinking to refugia during the glacial periods when the African climate was drier and cooler, expanding again during the interglacials when the warmth and the rainfall returned. The bonobo's ancestors moved through these expansions and contractions, surviving the contractions in the refugia, where the forest persisted, expanding their range as the forest expanded, and finding themselves, at the end of the last glacial maximum, approximately 12,000 years ago, in the vast connected forest that the current bonobo range occupies. The Congo River that created the bonobo formed during this period of forest history, carving a channel through the landscape that the ancestral great ape population on the south bank could not cross, and the speciation process that the separation initiated has produced in the 2 million years since, an animal whose external similarity to the chimpanzee conceals an internal world, whose investigation has occupied the comparative primatology for the past several decades without exhausting its complexity. The juvenile bonobo's social development is a process whose richness reflects the richness of the social environment that the bonobo community provides. The juvenile is embedded in a community of dozens of individuals whose social relationships with each other and with the juvenile are all sources of learning. Learning about hierarchy, about affiliation, about the management of tension, about the reading of emotional states in others, about the social resources that good relationships provide, and the social costs that poor relationships impose. The play behavior of juvenile bonobos is more varied and more sustained than the equivalent play in juvenile chimpanzees, and the research on bonobo play has found that the play contexts, the physical play, the social play, the object play, provide the practice ground for the behavioral skills whose adult expression is the bonobo's affiliative social system. The juvenile that has learned through play how to produce and to respond to the affiliative signals that reduce social tension is a juvenile that is building the social competence that the adult bonobo's success in the community's social life will require. The adult that this juvenile will become is an adult in a community that has been managing the same challenges, the tension between individual food needs and communal food sharing, between individual reproductive interests and communal social cohesion, between the competitive impulses that the evolutionary heritage of the ape shares with the chimpanzee and the affiliative mechanisms that the bonobo's social system has developed to manage those impulses. For 2 million years, the social system that the bonobo has developed is not a perfect solution to these challenges. It is a working solution, refined across 2 million years of selection, that has sustained the bonobo's communities in the Congo Basin forest through the full range of ecological and social stresses that the rainforest ecosystem presents. The night deepens around the sleeping community. The individuals whose platforms are closest together have been silent for hours. The last social interaction before sleep, a brief grooming session between 2 adult females, the vocal exchange of a mother and a juvenile settling into their adjacent platforms, has been absorbed into the dark, and what remains is the breathing of the community distributed through the canopy, each individual in the platform that its social position and its affiliative relationships have placed it in, resting in the dark of a forest that knows this species in the intimate way that old places know the things that have always been part of them. You are resting in your own dark tonight. The social world of your day has settled into wherever the dark puts it, and the dark is not requiring you to manage it. The affiliative bonds that sustain your daily life are in place. The tension that the day produced has gone where tension goes when the body releases it. What remains is the breathing and the dark and the slow, patient arrival of the rest that the night has been building toward since the moment the light went out. The bonobo in the canopy is breathing. You are breathing. The Congo Basin forest is breathing. All of it in the dark, in the slow exchange that life has always made with the night, giving the day's effort back to the dark in the form of the breath that comes and goes without management, without direction, in the rhythm that the body has always known. Let that rhythm carry you. The forest holds the bonobo, the night holds the forest, and the breathing holds you, as it has always held you, through every night that has ever been yours. Sleep now. The dawn in the Congo Basin comes with rain as often as without it, because the humidity of the closed canopy rainforest maintains the conditions for convective rainfall through the night and into the early morning in a way that the more open savanna environments do not sustain. The rain on the canopy at dawn is a different sound from the rain at midnight. It comes with the first light, or with the graying of the sky that precedes the light, and the community that has been sleeping through the night hears it as part of the transition from the darkness to the day, a sound that is part of the morning's arrival rather than a disturbance of the night's continuity. The bonobo community wakes gradually in the wet dawn. The first sounds are the contact calls of individuals checking the locations of their social partners, the peeping calls that locate the friend, the affiliate, the family member before the community's movement through the canopy begins for the day. The sleeping cluster reconstitutes itself as a waking social group in the first minutes of the morning. The individuals whose platforms were close together, finding each other again in the light that the dawn is providing. The community re-establishing the social awareness of each other's positions that the night's sleep had suspended. The day's management of the community's social life begins again. You do not need to begin yet. The dawn that is coming for you is not the Congo Basin's dawn. It is your own dawn in your own place, and it is not yet here. The darkness that holds you now is the darkness that remains, and it remains for as long as the rest continues, and the rest continues as long as the body needs it. Let the bonobo community wake into its forest. Let the rain fall on the canopy. Let the contact calls find their recipients. You are in the quiet that precedes all of this, in the place that the night made for you, and that the breathing is holding you in, gently and without urgency, until the morning that is yours arrives and finds you ready for it. The tool use of the bonobo in the wild is less elaborated than the orangutans or the chimpanzees, and the research on why this is has produced an interesting finding. In the environments where the bonobo lives, the foods that require tools to access are less abundant and less nutritionally important than the equivalent foods in the chimpanzee's range. The chimpanzee's nut cracking, which requires stone anvils and hammers and represents the most technically demanding tool behavior documented in the wild great apes, exploits food resources that are abundant in the West African forests where the behavior is most developed. The forests of the bonobo's range do not contain the same abundance of hard-shelled nuts, and the selection pressure for the development of the stone tool tradition has therefore been weaker. This does not mean the bonobo lacks the cognitive capacity for tool use. Managed population research has found that bonobos learn tool behaviors readily and transfer them to novel contexts with the flexibility that characterizes the cognitively sophisticated animal. The difference in tool use between the bonobo and the chimpanzee in the wild is a difference in ecological opportunity as much as a difference in cognitive capability. The bonobo has the hands and the brain that tool use requires. It has simply been living in a forest that has not, for the most part, provided the incentive for the elaborate tool traditions that the chimpanzee's forest has provided. The Louis Cotel field site in the Salonga National Park of the Democratic Republic of Congo is one of the primary sites of wild bonobo behavioral research, and the community of bonobos studied there has been under observation since 2002, providing a data set that is beginning to approach the temporal depth that the questions of bonobo social dynamics and life history require. The researchers who work at Louis Cotel describe the conditions of the fieldwork, the remoteness of the site, the difficulty of access, the logistical challenges of maintaining a research presence in one of the world's most challenging operating environments, with the mixture of difficulty and privilege that characterizes the long-term field research on great apes in remote locations. The bonobo community at Louis Cotel has revealed behavioral patterns that were not previously documented in any great ape, including the regular wading and swimming behavior in the forest streams and rivers that the community uses for foraging, and the prey-sharing behavior in which adult bonobos share hunted animal prey with other community members, in patterns that differ from the chimpanzee's prey-sharing in their inclusivity. More community members receive shares from a bonobo hunt than from the equivalent chimpanzee hunt, consistent with the bonobo's more broadly affiliative social system extending to the management of high-value food resources. The okapi, whose range overlaps with the bonobos in the dense forests of the Congo Basin's interior, is one of the forest's most extraordinary residents. A large mammal related to the giraffe, whose striped hindquarters and whose long dark tongue that wraps around the forest vegetation in the same reaching gesture that the giraffe's tongue uses to strip acacia leaves, are the visible expressions of an evolutionary history that has been playing out in the Congo Basin for millions of years in parallel with the bonobo's own evolutionary history. The okapi and the bonobo share the same forest but occupy different ecological niches. The okapi is a browser of forest vegetation, a shy animal that the forest's density conceals from most human observers, while the bonobo is a frugivore and a social primate whose canopy life brings it into contact with the forest from above. They encounter each other occasionally at the forest floor, and the research on bonobo responses to okapi encounters has found that the bonobo's response is curiosity rather than alarm, an investigation of the unfamiliar large mammal that reveals the bonobo's confidence in its forest and its interest in the novelty that the okapi represents. The forest that holds both is the forest that the conservation programs working in the Congo Basin are attempting to protect from the deforestation, the bushmeat hunting, and the agricultural expansion that are reducing its extent and its connectivity, in the same way that the equivalent processes are reducing the orangutans' rainforest in Borneo and Sumatra. The Congo Basin contains more than half of Africa's remaining tropical forest, and its conservation is a conservation challenge at a geographic and an organizational scale that exceeds any of the conservation programs currently operating within it. The bonobo infant clings to its mother's belly for the first months of its life and transitions to riding on her back as it grows larger and more confident in its own grip and its own balance. The mother carries the infant through the canopy and on the ground, adjusting her movement to accommodate the additional weight and the additional caution that carrying a dependent infant requires, avoiding the leaps that the infant's grip might not survive, choosing the routes through the canopy that the infant can hold on through, monitoring the infant's position and grip during the movements that the daily travel requires. The infant is learning throughout this period of being carried. It is learning the routes through the canopy, the locations of the productive fruit trees, the identities and the social relationships of the community members that the mother interacts with during the daily ranging. It is learning the social signals, the facial expressions, the vocalizations, the body postures that communicate emotional states between individuals, and that the infant will need to read and produce with accuracy to navigate the social life of the community it is growing up in. And it is learning the mother's management of social tension, the affiliative behaviors that she deploys in the social situations that require them, through the continuous observation that the infant's proximity to the mother provides. The infant bonobo is not a passive passenger. It is a student in the educational institution of the most intensive great ape childhood available on Earth, learning from the most capable teacher it will ever have. The silence that holds the Congo Basin in the deepest hours of the night is not the silence of emptiness. It is the silence of full occupation, a forest whose every layer is inhabited by organisms whose activity is simply below the threshold of the human ear's detection at the distances involved. The bacteria in the soil are metabolizing. The fungi are extending their hyphae through the leaf litter. The insects whose daytime calls have subsided into the quieter nighttime frequencies of the cricket and the moth are still present, still moving, still doing what they were doing. The forest is not asleep. It is in the quieter mode of its continuous activity, the same activity that has been sustaining the forest's biological community since before the bonobo's ancestors arrived in it. In this context, the bonobo's sleep is not a withdrawal from life. It is life in a different mode, the mode of maintenance and consolidation rather than the mode of activity and engagement. The sleeping bonobo in the canopy is as fully a part of the forest as the waking bonobo, present, breathing, connected to the same ecosystem that sustains it when it is awake, just less visibly active in its participation. You are in the quieter mode of your own continuous activity tonight, less visible in your participation, more present in the maintenance mode that the sleep provides, connected to the place you are in, to the breathing that continues, to the darkness that holds both, as fully and as completely as the bonobo is connected to its forest in the deep of the Congo night. The research on the bonobo's long-term memory for social partners has found that individuals who have been separated for years recognize each other upon reunion in ways that the behavioral response to the encounter reveals. The bonobo that re-encounters a community member after a long separation shows affiliative behavior, grooming, physical contact, the peeping calls of positive social engagement, rather than the investigation and assessment sequence that a stranger encounter produces. The memory of the individual and of the relationship that existed before the separation has been maintained across the years of the separation in a long-term social memory whose existence the reunion behavior demonstrates. The bonobo's long-term memory for social relationships is the cognitive foundation of the community's social continuity across the events, births, deaths, departures, and returns that change the community's composition across the years. The community is not simply the individuals who are present at any given moment. It is the accumulated history of the relationships between those individuals stored in the memories of the community members and expressed in the behavioral responses that the encounters between members produce. The community that the field researchers observe is the surface expression of a social history that the bonobos carry in their long-term memories and that the researchers can only partially reconstruct from the behavioral record. The night is very deep now. The breathing in the canopy is slow and regular. The contact calls that the community uses to locate each other have been silent for hours. Everyone knows where everyone is because the sleeping platforms are in the positions that the evening's social activity established, and the night has not produced the disturbances that would require the calls to locate. The female, who is the community's highest-ranking member, sleeps in the center of the cluster. Her son, whose social status reflects her own, is in a platform nearby. The adult males with the strongest female relationships are in the inner circle of the sleeping arrangement. The periphery holds the individuals whose social bonds with the central members are less strong. The social geography of the day has become the geography of the night, and the night holds it with the same indifference that the forest holds everything that it holds, without preference, without judgment, simply containing what is in it in the dark that is the same for everyone. You are in your own geography tonight. The center and the periphery of your own social world are where they are, and the night does not require you to manage them. The relationships that sustain you are in place. The bonds that have accumulated across the years are in place. The memories that connect you to the people and the places and the experiences that constitute your life are in place, ready to be re-engaged in the morning. Tonight they rest. Tonight you rest. The Congo Basin holds the bonobo. The night holds the Congo Basin. And the breathing that has been carrying you since this began is still carrying you now, into the depth of the rest that has been building across the hours, into the dark that holds everything the day has done, and that will release it, gently and without urgency when the morning comes. Sleep. The bonobo and the human share approximately 98.7% of their DNA, the same percentage as the chimpanzee. The two species represent the two closest living relatives of the human lineage, and the comparison between them illuminates, from two different evolutionary directions, the question of what the common ancestor of all three species was like, and what the evolutionary pressures of the past 6 million years have produced in each of the three lineages. The human chose the ground. The chimpanzee stayed in the forest and chose the hierarchical male coalition. The bonobo stayed in the forest and chose the affiliative female coalition. Three species, three social systems, three answers to the same starting point of a large-brained, socially complex primate in the tropical forest of equatorial Africa. The answer the human chose has produced the civilizations and the languages and the technologies whose products include the voice that is speaking to you right now, the device through which the voice is arriving, and the room or the space where you are listening. The answer the bonobo chose has produced, across 2 million years of refinement in the Congo Basin forest, a social system whose management of conflict through affiliation rather than aggression whose distribution of social power across the female coalition rather than its concentration in the male hierarchy, and whose maintenance of the mother-son bond into full adulthood represent a way of being a social great ape that the human lineage did not choose, but that the comparative research has found to be at least as successful by the biological metrics of the species' survival across the full range of conditions that the Congo Basin has presented. The bonobo chose affiliation. The forest held the choice. The night holds the forest. And you, in your own rest, in your own dark, are closer to the bonobo tonight than the waking hours allow. In the breathing that continues without management, in the body that is doing what bodies have always done in the dark, in the quiet that the night provides equally to the great ape in the Congo Basin canopy and to the human in whatever place the night has found you. The breathing continues. The dark holds. Sleep. The Wamba field site in the DRC, where the bonobo research program began in 1974 under the direction of Takayoshi Kano, is the longest-running bonobo research site in the world, and the community of bonobos that has been studied there across 5 decades has provided the foundation of what the comparative primatology knows about wild bonobo behavior. The disruptions that the civil conflicts of the DRC have produced at Wamba, the periods when the field station had to be evacuated, when the monitoring of the community was interrupted for months or years, when the conservation infrastructure that the research presence supports was reduced, have left gaps in the behavioral record that the research community has been working to fill with the continuous monitoring that the improved security conditions of recent years have allowed. The bonobos at Wamba have continued across the decades of the research program's presence, unaffected in their behavioral patterns by the observation that the research has conducted. The community that Kano first habituated to human presence in the 1970s has produced the generations of bonobos that the current researchers observe, and the social traditions of the community, the affiliative patterns, the female coalition structures, the food-calling behaviors have been transmitted across those generations in the same cultural transmission processes that the research has documented in all the great ape populations where the temporal depth of the observation is sufficient to detect intergenerational transmission. The bonobo's relationship with the forest's plant foods extends across a dietary range that the research has found to be among the broadest in the great apes. The bonobo eats more than 100 plant species in the populations where the dietary composition has been studied, including the terrestrial herbaceous vegetation that grows on the forest floor, whose consumption by the bonobo supplements the fruit diet during the lean seasons when the canopy fruit is scarce. The terrestrial herbaceous vegetation, the leaves, the stems, the pith, and the flowers of the ground layer plants, is a food resource that the orangutan and the chimpanzee also use in lean seasons, but that the bonobo uses more extensively and more reliably across the annual cycle than either of the other great apes. The dietary breadth of the bonobo is one of the factors that has allowed it to maintain larger community sizes in the Congo Basin than the chimpanzee maintains in equivalent food environments, because the ability to fall back on the terrestrial herbaceous vegetation when the preferred fruit is scarce reduces the energetic stress of the lean season and allows the community to remain in larger groups rather than dispersing into smaller subgroups as the chimpanzee does when the fruit is scarce. The larger community size sustains the social complexity that the bonobo's affiliative system requires: more partners, more grooming relationships, more social opportunities. And the dietary breadth is one of the ecological foundations of the social complexity that makes the bonobo what it is. The light that will come in the morning will find the community still in the canopy, the sleeping platforms holding their occupants through the last hours of the night in the darkness that has covered everything equally. The highest-ranking female and the lowest-ranking juvenile, the adult male with the strongest female relationships and the adult male at the periphery whose social bonds are less developed, the mother with the infant clinging to her belly, and the old female whose years in the community have made her one of its most knowledgeable and most socially embedded members. The light will find them all in the canopy, and the canopy will hold them as the day begins, and the day will ask of them what the day always asks: the management of the food, the management of the social tensions, the maintenance of the bonds that sustain the community, and the community sustains the individuals who are its members. But that is the day's work. Tonight is still tonight. The dark is still here. The breathing is still carrying you, as it has been carrying you since the light went out, into the rest that the body knows how to find, and that the night knows how to provide, and that the darkness holds with the same patient, unhurried generosity that the Congo Basin forest holds the sleeping bonobo community in its canopy. You are held. The breathing continues. The night remains. Let it. The research on the bonobo's vocal communication has found a degree of contextual flexibility that the comparative vocal communication research has found to be more developed in bonobos than in chimpanzees. The same call used in different social contexts carries different meanings that the listening animals appear to decode accurately, suggesting a rudimentary semantic flexibility in the call system that goes beyond the simple one call, one meaning model that the earlier animal communication research assumed. The peeping call that serves as a contact call between community members also functions as a food call and as a play initiation call, and the context in which it is produced, the caller's behavioral state, the social situation, the presence or absence of food, is the information that the listeners use to decode which meaning the call is carrying in the current situation. The research on bonobo call combinations has found that individuals produce call sequences, 2 or 3 calls of different types in rapid succession, in ways that appear to convey social information that neither call alone would convey. The sequential combination of a contact call with a food call, for example, appears to recruit a social partner to a food location in a way that the food call alone does not reliably produce. Whether this represents a form of protogrammar, a compositional call system whose meaning is partly determined by the combination of elements, is a question that the bonobo vocal communication research is actively investigating. The night sounds of the Congo Basin include sounds that the human ear does not easily categorize. The low-frequency vocalizations of the forest elephants that move through the forest floor in the darkness. The calls of the night birds whose identification requires years of dedicated fieldwork in this forest. The sounds of the streams and the rivers that drain the basin's flat interior toward the Congo River that eventually carries all of this water to the Atlantic. These sounds form the acoustic background against which the bonobo's nighttime vocalizations occur. The occasional contact call between community members who have been disturbed by something in the night, the alarm response to the sound of a large animal moving below the sleeping platforms, the quiet exchanges of a mother reassuring an infant that has woken in the dark. The sounds of the night in the Congo Basin are the sounds of a biological community that has been occupying this forest for longer than the bonobo has, longer than any primate has, in the continuous overlapping, mutually sustaining activity that the ecological concept of the community describes, and that the darkness of the night does not interrupt but only makes less visible. The night sounds are life, in the mode that life operates in when the sun goes down, and the diurnal species rest, and the nocturnal species take over the task of being alive in the same forest. Let those sounds be the last ones the mind reaches for before the reaching stops. The Congo Basin in the dark. The bonobo in the canopy. The breathing that connects them to the forest and connects you to the breathing. Everything in its place. Everything in the dark. Everything held by the night that has always held everything that needed holding. Sleep. Let the body settle. Let the breath slow. You don't need to do anything with this hour except receive it. There is a forest in western Tanzania on the eastern shore of Lake Tanganyika, where a community of chimpanzees has been studied continuously since 1960. The forest is called Gombe, and the research that began there more than 60 years ago has produced the most detailed picture of any wild animal community that the behavioral science has ever assembled. The chimpanzees of Gombe are known individually, their faces, their voices, their social relationships, their behavioral quirks, their histories. The researchers who began the study in the 1960s have watched infants grow into adults, adults age into elders, and elders die and be replaced by the generation whose births the research recorded. The community has a history that extends across 6 decades of human observation and that history is contained in the field notes and the behavioral records of the research program that has been accumulating it since the year that Jane Goodall arrived at the lakeshore with a notebook and a pair of binoculars. Let that continuity be the quality you rest in as this hour begins. 60 years of watching the same community, the same forest, the same lake visible through the trees at the edge of the chimpanzees' range. The same questions, asked with increasingly sophisticated methods, producing increasingly detailed answers that have changed what the science understands about what an animal can be. Subscribe right now and help us reach 1,000 subscribers. Hit that button. It costs you nothing, and it keeps this channel going. Drop a comment telling us where in the world you are watching from and what time it is. We read every single one. The chimpanzee is the animal that forced the science to revise its understanding of the boundary between human and non-human. When Goodall observed in 1960 a chimpanzee at Gombe stripping the leaves from a grass stem and inserting the stem into a termite mound to extract the termites that adhered to it, the first documented observation of tool manufacture in a non-human animal, the finding required the revision of the definition of tool use that the behavioral science had been operating with. The consensus understanding at the time was that the making and using of tools was an exclusively human behavior, one of the defining characteristics of the human species. Goodall's telegram to Louis Leakey, her mentor and the paleontologist who had arranged the Gombe research, reported the observation and suggested that it required either a revision of the definition of tool use, a revision of the definition of the human, or acceptance of the fact that chimpanzees qualified as human by the existing definition. Leakey's response, in the formulation that became one of the most quoted sentences in primatology, was, "Now we must redefine tool, redefine man, or accept chimpanzees as humans." The science chose the first option. It redefined tool to encompass the manufacture of objects for a defined purpose, and accepted that the chimpanzee, and subsequently several other animal species, had crossed the threshold that the redefined definition required. The boundary between human and non-human had been moved. It has been moved several times since, as the research on chimpanzee cognition, social behavior, and cultural transmission has continued to find capabilities whose presence in any animal had previously been assumed to require the human nervous system. The forest is very quiet now. The lake is visible through the trees at the edge of the range, catching the last light in the way that deep water catches light. Slowly, completely, as if the water is taking the light rather than simply reflecting it. The chimpanzees are in the canopy, the sleeping platforms distributed through the trees, in the spatial arrangement that the day's social dynamics have produced. Let the image of the lake in the last light be something the mind rests on for a moment before it releases the need for images at all. The chimpanzee shares approximately 98.7% of its DNA with the human species, the same percentage as the bonobo. This number is large enough to be meaningful and small enough to be underestimated. The 1.3% that separates the human genome from the chimpanzee genome encompasses the differences in brain development, language capability, bipedal locomotion, and the cognitive capabilities that the human's expansion across the planet and the chimpanzee's confinement to the tropical forests of sub-Saharan Africa reflect. The genetic difference is small. Its phenotypic consequences are large. The same biology, diverged 6 million years ago, has produced by the accumulation of those small genetic differences an animal whose civilization includes the observation of chimpanzees and an animal being observed. The chimpanzee's brain, which weighs approximately 400 grams in adults, is substantially larger relative to body size than the brains of most other mammals, but substantially smaller than the human's 1,350 grams. The size difference is accompanied by organizational differences. The human frontal cortex, which is disproportionately large relative to total brain volume and which is associated with the planning, the language, and the self-regulation that most distinguish human cognition from chimpanzee cognition, is proportionally larger in the human brain than in the chimpanzee brain in ways that the brain imaging and the neuroanatomical research have characterized in detail. The chimpanzee's brain is not a smaller version of the human's. It is a differently organized version of the shared primate neural architecture, and what the chimpanzee can do with it continues to surprise the research that has been studying it for more than 60 years. The social life of the chimpanzee community is organized around the male hierarchy in a way that the bonobo community's social life is not, and the male hierarchy's dynamics are among the most studied aspects of chimpanzee behavioral ecology. The adult males of the community compete for position in a linear dominance hierarchy, whose highest position, the alpha male, provides preferential access to food resources, to reproductive opportunities with females in estrus, and to the deference of all other community members in the social interactions whose outcomes the hierarchy mediates. The alpha male's position is not simply the position of the physically largest or the physically strongest male in the community. It is the position of the male who has assembled and maintained the most effective coalition, the network of supporting allies whose combined competitive capability makes the alpha's position secure against the challenges that the males below him are always assessing the possibility of. The alpha who loses the support of his primary coalition allies loses his position, regardless of his individual physical capability, because the chimpanzee political system is a coalition system in which the alliance is the primary currency of competitive success and the individual's strength is only one of the resources the alliance draws on. The political intelligence that the chimpanzee's coalition system requires, the ability to track the relationships between other individuals, to read their current alliance states and their likely future loyalties, to intervene in conflicts between other males in ways that advance one's own coalition position, is a social cognitive capability whose characterization by the primatologist Frans de Waal in his studies of captive chimpanzee communities at the Arnhem Zoo in the Netherlands produced one of the most significant contributions to the understanding of primate social intelligence in the history of the field. De Waal's term for the behavior, chimpanzee politics, was not metaphorical. The power dynamics he observed in the Arnhem community were the same dynamics that the political science had been studying in the human context. The forming and the breaking of alliances, the strategic management of information about one's intentions and capabilities, the exploitation of third-party relationships to advance one's own competitive position. The sleeping platform in the canopy is the chimpanzee's nightly construction, the same bent branch structure that the orangutan and the bonobo build, adapted to the dimensions and the weight of the chimpanzee's body, and to the characteristics of the trees available in the chimpanzee's range. The research on chimpanzee nest construction has found that the nests are built with a consistency of structural design that the research interprets as reflecting a shared building tradition transmitted within the community. The young chimpanzee learns nest construction by watching adults, as the young orangutan learns the leaf umbrella by watching its mother. The nest is cultural in the same sense that any socially learned behavioral tradition is cultural. It is produced by the same learning mechanism and maintained by the same transmission process that produces the other cultural traditions of the community. The nest that the chimpanzee builds tonight will be used once. Unlike the orangutan, which may use the same nest platform for multiple nights in areas where the food resources keep it in the same location, the chimpanzee builds a fresh nest each evening, a behavior whose sanitary benefits in reducing the parasite loads that accumulate in a regularly used sleeping site. The research has found to be real and functionally significant. The fresh nest is built in approximately 5 minutes from the materials available at the sleeping site, in the design that the chimpanzee's construction tradition provides. The bed is made fresh every night, and the morning finds it empty and already beginning to decompose back into the forest. There is something in this that speaks to the quality of rest the chimpanzee achieves, not the permanence of the orangutan's decades of platforms, but the freshness of the each night construction, the sleep taken in the newly made space before the forest takes it back. Each night a new bed, each morning the forest reclaims it. The culture of the chimpanzee, the set of behavioral traditions transmitted by social learning within communities and varying between communities in ways that reflect local learning rather than genetic differences, is one of the most thoroughly documented examples of non-human culture available, and the research that has characterized it has found a breadth of cultural variation between chimpanzee communities that the initial discovery of tool use at Gombe did not anticipate. The West African chimpanzees of the Thai forest in Ivory Coast use stone hammers and stone anvils to crack open oil palm nuts, a tool-use tradition that requires the transport of the hammer stone to the anvil site, the placement of the nut on the anvil, and the application of the hammer to the nut with sufficient force to crack the shell without crushing the kernel inside. The tradition has been transmitted within the Thai forest community across multiple generations of individuals, and the research on its development in young chimpanzees has found a learning trajectory that spans years. The juveniles who begin attempting to crack nuts at age 3 or 4 are still not achieving the efficiency of adult crackers at age 6 or 7, and the full mastery of the technique develops across the years of childhood and adolescence. The Gombe chimpanzees do not crack nuts. Oil palms exist in the Gombe area, and the Gombe chimpanzees consume the oil palm fruit, but they do not use stone tools to crack the hard kernels that the Thai forest chimpanzees crack open and consume. The research has proposed that the absence of the nut-cracking tradition at Gombe reflects the absence of the local cultural transmission of the tradition rather than the absence of the cognitive capability to perform it. The Gombe chimpanzees, if exposed to the Thai tradition, would likely learn to crack nuts. The tradition has simply not taken hold at Gombe, and its absence is cultural rather than cognitive. The research on chimpanzee cultural variation has now catalogued dozens of behavioral traditions that are present in some communities and absent from others. The tool techniques used to extract termites or honey or ants, the grooming postures that the research has found to vary between communities, the rain dance-like displays that some communities perform at the onset of rain and that others do not. Each tradition's distribution across the geographic range of the chimpanzee reflects the history of its cultural transmission, where it originated, how it spread, where it failed to spread across the geographic or the social boundaries that constrain the movement of behavioral innovations through the community network. The forest around the sleeping community at Gombe holds all of this history, the decades of field notes and the behavioral observations, and the individual life histories and the cultural traditions and the political dramas of the male hierarchy, in the form of the living chimpanzees who are the current generation of the community that the research has been watching since 1960. The community that exists tonight is the community that the next decades of the research will continue to watch, as the infants born this year grow into the adults that the research will track across the full arc of their lives. Let the long view of the research, 60 years of watching, with the next 60 already planned, be restful in the way that deep time is restful. The forest has been here longer than the research. The chimpanzees have been here longer than the forest, in the sense that the chimpanzee lineage predates the current configuration of the Gombe forest. The lake has been here longer than the chimpanzees. The rift valley that contains the lake has been here for 30 million years. You are resting in a world of very old things, and the very old things are indifferent to the urgency that the day produced. They were here before the urgency. They will be here after it. In the meantime, they hold everything that is in them, including you, in the unhurried dark of a night that is the same night it has always been. The chimpanzee's vocalization system is one of the most studied animal communication systems in behavioral science, and what the research has found in it illuminates both what the chimpanzee can communicate and the gap between its communication capability and the human language that its nearest relative has developed. The pant hoot, the long-distance call that the chimpanzee produces to announce its presence and its location to the community, is composed of 4 phases: the introduction of soft hoots, the build-up of increasing amplitude, the climax of screaming vocalizations, and the letdown of decreasing amplitude. The entire sequence lasts approximately 15 seconds and carries through the forest for distances of up to 2 kilometers. The research on pant hoot production and response has found that the call encodes information about the caller's identity. Each individual's pant hoot has distinctive acoustic properties that the research has found to be sufficient for individual identification by both the chimpanzees and the researchers who have listened to them for years, and about the caller's behavioral state and social context. The chimpanzee's vocal communication is not a language, It lacks the combinatorial productivity, the ability to combine finite elements in unlimited ways to express unlimited meanings that the human's language possesses. But it is not the simple one-call, one-meaning system that the earlier comparative communication research assumed. The research has found that chimpanzees produce call combinations whose meaning is not simply the sum of the individual calls' meanings, that they attend to the sequential structure of call sequences in ways that suggest they are processing the sequence rather than individual elements, and that they can learn to associate arbitrary sounds with meanings in training paradigms that provide evidence for referential signaling at the level of the concept rather than the immediate perceptual stimulus. The gap between what the chimpanzee can do with sound and what the human does with language is a gap whose characterization by the comparative linguistics and the cognitive science has produced a large and still evolving literature. What the literature agrees on is that the gap is smaller than the earlier comparative science assumed, and that the neural architecture that the chimpanzee's vocal and cognitive behavior draws on is the architecture from which the human's language capability evolved, rather than an entirely different system that the human evolved from scratch. The night is very deep now. The lake is dark beyond the edge of the forest, its surface absorbing the light of the stars and giving nothing visible back. The chimpanzee community is in the canopy, the sleeping platforms distributed through the trees in the arrangement that the social life has produced, each individual in the position that the day's political dynamics, its feeding requirements, and its affiliative relationships have placed it in. The political dynamics that placed the alpha male in the central position of the sleeping cluster and the peripheral males at the edges are the same dynamics that will resume in the morning when the community descends from the canopy and the day's management of the hierarchy begins again. The alliances that were reinforced by the grooming sessions of the afternoon are the alliances that will be tested in the morning's competitive encounters. The tensions that were not resolved by the day's social interactions are the tensions that will find their resolution or their escalation in the interactions that the morning produces. But all of that is the morning's work. The night offers something different. The night offers the interval between one day's management and the next day's management. And in that interval, the chimpanzee sleeps, not the fragmented standing sleep of the zebra or the brief installments of the giraffe, but the extended, recumbent, deeply restorative sleep that the platform in the canopy makes possible. The research on chimpanzee sleep has found that the chimpanzees spend approximately 9 to 10 hours per night in the nest, sleeping for most of that time in the postures that the nest's cushioning supports, and that the sleep includes both slow-wave sleep and REM sleep, in proportions that the comparative sleep science has found to be similar to the proportions in human sleep. The sleeping chimpanzee is doing the same cognitive work that the sleeping human is doing. The consolidation of the day's memories, the processing of the day's emotional content, the maintenance of the neural systems whose proper function the sleep provides. The chimpanzee that spent the day navigating the political dynamics of the male hierarchy, making the alliance decisions that its competitive position required, and managing the social information whose accumulation is the foundation of the chimpanzee's social intelligence, is consolidating all of this in the sleep that the night provides. The research on sleep deprivation in chimpanzees has found effects on cognitive performance and social behavior that parallel the effects of sleep deprivation in humans, the impaired learning, the reduced social sensitivity, the increased irritability that the research on human sleep deprivation has characterized. The chimpanzee needs sleep for the same reasons the human needs sleep, because the neural systems that the chimpanzee uses for its complex social and cognitive life are the same neural systems, in their basic architecture, that the human uses for the equivalent functions. You are using those neural systems right now in the mode that the sleep provides, the maintenance mode, the consolidation mode, the resting mode that the cognitive systems require to function well in the morning. The chimpanzee in the nest understands this in the behavioral sense of an animal, whose biology has been calibrated for exactly this nightly routine across millions of years of evolution in the forest. You understand it in the more explicit sense of an animal that can read about it in a science that has been characterizing the neural mechanism for decades. Both forms of understanding lead to the same place, the nest in the canopy, the breath in the dark. the rest that the night provides. The chimpanzee is in its nest. The forest holds the nest. The night holds the forest. And the breathing holds everything else, the day's politics and the night's quiet, and the lake at the edge of the forest, and the 60 years of research, and the 6 million years of evolution that produce the animal in the nest, and the animal listening to this voice in the dark, and the shared 98.7% of the genome that connects them across the 6 million years. The breath comes in. The breath goes out. The forest is dark. The lake is dark. The chimpanzee is asleep in the nest it built tonight and will not use again. You are in the rest that the night built for you, and the night will hold it until the morning that is coming carries you into the next day with whatever the sleep has produced for you in the interval between. Let the interval be what it is. Let the breathing carry you through it. Let the morning come when it comes. Sleep. The mother-infant relationship in the chimpanzee is the most intensively studied dyadic relationship in the primate behavioral literature, and the findings it has produced illuminate both the depth of the social bond and the mechanism of the cultural transmission that makes the chimpanzee's behavioral traditions the culturally sustained phenomena they are. The infant clings to the mother's belly for the first months of life, transitioning to riding on the mother's back as it grows larger and stronger, and remaining in continuous proximity to the mother for the first 4 to 5 years of its life. During this period, the infant observes everything the mother does, every food choice, every tool use, every social interaction, every travel decision, from a position of close proximity that makes the observation as detailed as any learning opportunity in the animal world. The infant that is watching its mother strip the leaves from a grass stem and insert it into a termite mound is watching not just the behavior, but the context, the location of the productive mound, the season in which termite extraction is most productive, the technique for reading the mound's activity level before investing the effort of the extraction. The learning that the infant is doing during these years of maternal proximity is not the learning of a student being taught. The mother does not modify her behavior to facilitate the infant's learning. She does what she does, and the infant's learning system, the primate learning system that has been shaped by millions of years of selection for social learning in a socially complex environment, extracts the information from the observation and builds from it the behavioral repertoire that the adult chimpanzee will eventually be able to deploy. The chimpanzee's hunting behavior is one of the most discussed and the most debated aspects of its behavioral ecology, partly because the hunting involves the killing of other primates, primarily red colobus monkeys in the Gombe and the Thai forest populations, in a predatory behavior whose observation has forced a reconsideration of the chimpanzee's place in the trophic structure of the ecosystems it inhabits. The hunt is cooperative in the Thai forest population, where the males take different positions, blocking escape routes, pursuing the prey, waiting at the base of the tree for the monkey that has been driven down, in a coordinated behavioral sequence that the research has characterized as one of the most sophisticated cooperative hunting behaviors documented in any non-human animal. The coordination is achieved without explicit communication during the hunt. Each hunter reads the behavior of the other hunters and adjusts its own position and behavior in response, in a real-time coordination that the research on the hunt's moment-by-moment dynamics has found to be genuinely collaborative rather than simply individually opportunistic. The meat from a successful hunt is shared, but not equally, and the distribution of the carcass reveals the political dynamics of the male hierarchy at work in the management of a high-value, shareable resource. The alpha male typically takes the carcass or a large portion of it and shares it selectively with his coalition allies, with females in estrus whose cooperation he is cultivating, and with the males below him whose loyalty he is reinforcing. The sharing is a political tool as much as a nutritional exchange, and the research on meat sharing has found that the individuals who receive meat are more likely to support the sharer in subsequent agonistic encounters. The forest at Gombe in the dry season has a quality that the wet season's lushness conceals. The canopy is thinner, the light more direct on the forest floor, the paths through the undergrowth more visible and more traveled by the chimpanzees, who are moving more widely in search of the fruit, whose distribution the dry season has made more scattered. The lake is visible through the trees more frequently, and in the morning the mist over the lake catches the early light in a grey gold that the chimpanzees moving through the forest edge see from above. The researcher, who has spent decades watching this forest, describes the dry season's thinning of the canopy as the time of year when the chimpanzees are most visible, when the observation from below can track the movement of individuals through the canopy in a way that the wet season's dense leaf cover prevents. The behavioral data that has characterized the chimpanzee's dry season food choices, its ranging patterns, and its social dynamics has been collected in the hours when this visibility is highest. And the picture of the chimpanzee's dry season ecology that the research has produced is a picture of an animal managing the lean months with the same cognitive resources it brings to the abundance of the wet season. The spatial memory of the food tree locations, the social intelligence of the coalition management, the flexibility of the food choice that allows the lean season's diet to include bark and insects and soil in proportions that the wet season's fruit abundance makes unnecessary. The research on chimpanzee self-recognition, the mirror test, whose administration to chimpanzees in the early 1970s by Gordon Gallup Jr., produced one of the most influential findings in the history of comparative psychology, established that chimpanzees recognize their own reflections as reflections of themselves rather than as representations of other chimpanzees. The test involves the administration of a mark to the face of the anesthetized animal, the animal's recovery in the presence of a mirror, and the recording of whether the animal uses the mirror to examine the mark, which it can see in the reflection, but not directly. Chimpanzees in Gallup's original study used the mirror to inspect the mark, touching the mark on their own face while looking at its reflection rather than reaching toward the reflection. The research interpreted this as evidence that the chimpanzee has a concept of the self, that it recognizes the reflection as a representation of its own body rather than another individual. The self-concept that the mirror test demonstrates is one of the cognitive foundations of the social intelligence that the chimpanzee's political life requires. An animal that can track its own state, its own coalition position, its own competitive history with other individuals, and its own likely future in the community's hierarchy is an animal whose self-model is a resource for the social reasoning that the hierarchy's management demands. The mirror test reveals the surface of a cognitive iceberg whose depth the decades of research on chimpanzee social intelligence has been plumbing without reaching the bottom. The conservation situation of the chimpanzee is the conservation situation of the tropical forest of sub-Saharan Africa, and the prognosis for both reflects the same tension between the economic development of the range countries and the biological requirements of the species that the great ape conservation programs have been navigating for decades. The 4 subspecies of chimpanzee, the Western, Central, Nigeria, Cameroon, and Eastern, are all classified as endangered, with population estimates that range from fewer than 6,000 for the Nigeria-Cameroon subspecies to approximately 180,000 to 250,000 for the central subspecies. The aggregate population across all 4 subspecies has declined by approximately 50% since 1970, driven primarily by habitat loss and by the bushmeat hunting, whose commercial scale in the Congo Basin and in West Africa represents one of the most significant wildlife mortality factors in the chimpanzee's range. The legal framework that protects chimpanzees across their range is a framework whose enforcement is as uneven as the institutional capacity of the range countries varies across the geographical extent of the chimpanzee's distribution. The formal protection of the chimpanzee as a nationally protected species in every range country exists on paper in every range country. The practical enforcement of that protection in the remote forest areas where the hunting and the habitat conversion are most actively occurring is a different matter, dependent on the ranger capacity, the political will, and the economic alternatives to bushmeat and forest conversion that the range country governments have or do not have available to them. The night in the Gombe forest carries the sounds of Lake Tanganyika, the world's second deepest lake, whose depth reaches nearly 1,500 meters. and whose water has been accumulating the sediment of the Rift Valley's biological productivity for 9 to 12 million years, in the gentle lapping of the lake's waves against the rocky shore at the forest's edge. The lake sounds carry through the forest in the still air of the night, and the chimpanzees in the canopy above can hear them. The same sounds they have heard every night of their lives, the same sounds that the generations before them heard, in the same forest, on the same shore of the same lake. The continuity of this place, the lake that has been here for 12 million years, the forest that has been here for millions of years, the chimpanzee lineage that has been in the forests of equatorial Africa for even longer, is the continuity that the research at Gombe has been witnessing for 60 years, and that the individuals of the community being watched have been living for the spans of their individual lives. The oldest female chimpanzees at Gombe are animals in their 60s, who were born before the research began and who have lived in the same forest, with the same lake at its edge, through the entire span of the research program's existence. They were here before the research arrived. They will be here, their descendants, the community that their lives have shaped, after the research is done. The lake is here, the forest is here, the breathing is here. Let the lake's sound be the sound that carries you the rest of the way tonight. The soft, regular lapping of water against the shore of a lake that has been receiving the same sound from the same shore for 12 million years, and that will be receiving it 12 million years from now, in the patient indifference of a geological feature that has no relationship to the urgency that the day produced. The lake is indifferent to the urgency. The night is indifferent to the urgency. And you, in the rest that the night is holding for you, can be indifferent to the urgency too. Just for tonight, just for this hour, just for the breathing that is carrying you, without urgency, through the dark, toward the morning that is building itself on the other side of the sleep you are entering. The chimpanzee is asleep in the nest it built tonight. The lake is lapping at the shore. The forest holds everything. Let it hold you too. The reconciliation behavior that follows intra-group conflict in the chimpanzee is one of the behavioral discoveries whose documentation transformed the field's understanding of the social function of aggression in primate groups. De Waal's observation, in the captive Arnhem community, that chimpanzees who had been involved in aggressive encounters frequently sought out and engaged in affiliative contact with their former opponent in the minutes following the conflict, the behavior he called reconciliation, was a finding that the field had not anticipated, partly because the focus on the conflict itself had obscured the post-conflict behavior, whose occurrence the careful behavioral sampling that De Waal's methodology employed detected. The reconciliation behavior, a kiss, a hug, a grooming session, or a simple approach and contact between former opponents, functions to repair the social relationship that the conflict has disrupted, reducing the probability that the conflict will continue and restoring the tolerant relationship that the two individuals' regular social proximity requires. The research on reconciliation has found that it is more likely to occur between individuals with strong prior social bonds, that it occurs more quickly after conflicts over high-value resources than after conflicts over low-value resources, and that its occurrence reduces the post-conflict stress indicators, the self-scratching, the yawning, and the physiological arousal that the endocrine research has found to accompany social conflict, more reliably than the absence of reconciliation. The chimpanzee that approached its former opponent this afternoon with the touch and the mutual grooming that ended, the conflict is a chimpanzee that has done something whose social function the research now understands well, and whose emotional function, whether the chimpanzee experiences something that resembles the relief of a repaired relationship, the research is still working to characterize. The long call of a chimpanzee heard from a distance in the Gombe forest is a sound that carries all of the individual information described earlier: the caller's identity, the caller's location, the caller's behavioral state. But that arrives at the listener's ear as something more immediate than information. It arrives as presence. The sound of the distant pant-hoot fills the forest in the way that large sounds fill enclosed spaces, and the individuals who hear it respond to it not simply with behavioral adjustments, but with the social awareness of a presence that the distance and the forest density prevent from being visible. The chimpanzee's acoustic community, the set of individuals who are within hearing range of each other's long-distance calls at any given time, is larger than its visual community. The chimpanzee knows who is in its acoustic neighborhood before it knows who is in its visual neighborhood, and the management of the social relationships that the community requires is conducted partly through the acoustic space that the pant hoot occupies. The silent chimpanzee that is not calling is a chimpanzee that is not participating in the acoustic community's social signaling, and the research on pant hoot calling rates across individuals and across contexts has found that the calling behavior is responsive to the social situation in ways that reflect the social function of the call. Individuals call more when they are joining other individuals, when they have found a large food source, and when they have had an agonistic encounter, in all of which the acoustic advertisement of their presence and their state is socially meaningful. The chimpanzee's experience of the night, as best the behavioral research can characterize it, is the experience of a social animal in a forest whose nighttime sounds are familiar. The sounds of the community members in the adjacent nests, the sounds of the nocturnal animals whose presence in the forest the chimpanzee has learned to read as background rather than as alarm, the sounds of the lake and the wind that the forest's edge allows through on calm nights. The chimpanzee that has been watching this forest for 30 or 40 years knows its nighttime sounds as well as its daytime sights, and the departure from the familiar nighttime acoustic palette is the signal that wakes it from its nest in the way that the familiar sounds allow it to sleep through. The research on sleep quality in great apes has found that the chimpanzees who build their nests in the more structurally stable trees in their range, the trees whose branches flex less in the wind and whose height and position reduce the exposure to the temperature fluctuations and the rainfall that the night brings, sleep more and show fewer nighttime disturbances in the behavioral records of the studies that have observed sleeping chimpanzees with the remote cameras and the acoustic monitors that make nighttime observation possible. The nest quality matters. The tree quality matters. The microclimate of the sleeping site matters. The chimpanzee's choice of where to build the night's nest reflects the accumulated knowledge of the territory's sleeping sites, whose quality the individual has assessed across the years of its residence in the range. The dawn at Gombe comes with the sounds of the lake and the first calls of the forest birds, and the chimpanzee community's transition from the sleep to the day begins with the sounds that the individuals make as they wake in their nests, the stretching and the yawning and the soft calls that the community members exchange in the early morning before the descent from the canopy begins. The alpha male's first pant hoot of the morning carries through the forest to announce the day's beginning to the community, and the responses from other community members produce the acoustic picture of who is where in the forest that the community's spatial awareness requires before the group's daily ranging can begin. The day begins with the communication of presence. Who is here? Where is here? What does here look like this morning? The community assembles its awareness of itself before it begins its movement through the forest, and the assembly is acoustic before it is visual, because the forest's density makes the acoustic channel the broader reaching medium for the long-range social awareness that the community needs. You do not need to assemble your awareness this morning. The morning is not yet here. The community of your day is where it is, and the awareness that will find it is not yet required. What is required right now, what the night is providing and what the breathing is continuing, is the interval between yesterday's awareness and tomorrow's in the place that the rest has made and that the sleep is sustaining. The chimpanzee is in its nest. The lake is lapping at the shore. The forest is holding everything in it, and the breathing is holding you in the same dark, in the same quiet, in the same patient rest that the night has always provided to everything that has found its way to the appropriate place for the sleeping hours and allowed the dark to do what the dark has always done. Sleep now. The morning will come when it comes. The fruit that the chimpanzee depends on in the forest is not distributed evenly across the landscape or consistently across the seasons. The tropical forest's fruiting phenology, the timing of fruit production across the tree species that make up the forest, is complex and partially predictable at the level of the individual tree species and largely unpredictable at the level of the individual tree. The chimpanzee that knows its forest knows which tree species fruit at which times of year, and in which environmental conditions and its ranging behavior reflects this knowledge in the routes it takes through its home range and the areas it prioritizes at different times of the seasonal cycle. The mental map that sustains this foraging intelligence is one of the most complex spatial temporal memories documented in any non-human animal. The chimpanzee is tracking not just where the food trees are, but when they produce. A temporal dimension of the spatial memory that requires the integration of environmental signals, the greening of new leaves, the flowering that precedes fruiting, the rainfall patterns that correlate with fruiting in some species, with the remembered history of each tree's production across previous years. The chimpanzee that moves toward a distant fig tree on the basis of its memory of the tree's previous productivity at this time of year in these environmental conditions is doing something cognitively demanding, whose neural basis the research on primate hippocampal function is still working to fully characterize. The relationship between the chimpanzee and the forest's ecosystem is a relationship of mutual shaping that the long evolutionary history of the species in the forest has produced, and that the current conservation crisis is dismantling. The chimpanzee is a seed disperser for the fruiting trees that constitute its primary food. The seeds that pass through the chimpanzee's digestive tract and are deposited in the dung across the ranging area of the individual contribute to the regeneration of the forest, in the same way that the bonobo's seed dispersal and the orangutan's seed dispersal contribute to the regeneration of their forests. The chimpanzee ranges over larger areas than most other seed dispersers in its ecosystem and carries seeds in its gut for longer before depositing them, making it one of the most effective long-distance seed dispersers in the forest communities it inhabits. The forest that the chimpanzee maintains through its seed dispersal is the forest that maintains the chimpanzee through its fruit production. They are sustaining each other in the same mutual dependency that characterizes the other great apes' relationships with their forests. The forest fragment that no longer contains chimpanzees is a forest fragment that has lost one of its primary seed dispersers, and the long-term consequences of this loss for the forest's regeneration are consequences that the research on seed dispersal in defaulated forests has found to be significant and difficult to reverse. The chimpanzee's conservation is therefore the conservation of the forest's regeneration capacity, and the forest's conservation is the chimpanzee's conservation, in the same circular dependency that the evolution of both has produced. The long-term research at Gombe has produced findings about individual life histories in wild chimpanzees whose depth is unmatched in the non-human primate literature. The research has documented the full lifespans of multiple individuals, from birth to death, and the behavioral data from these individual life histories has allowed the demographic analysis of survival rates, reproductive success, and the factors that predict the outcomes of the individual life across the full course of the chimpanzee's existence in the wild. The findings from this demographic analysis have found that the quality of the maternal relationship in the first years of life predicts the individual's survival, reproductive success, and social outcomes in the adult years in ways whose persistence across the lifespan illuminates the long reach of early developmental experience into the adult phenotype. The chimpanzees at Gombe, whose mothers were alive and socially present during their development, showed better adult outcomes across multiple metrics than the chimpanzees whose mothers died or were otherwise absent during the critical early developmental period. The mother's presence is not simply a source of milk and protection in the first years of the infant's life. It is a developmental context whose quality shapes the nervous system of the growing chimpanzee in ways whose effects the research has been able to trace across decades of subsequent behavioral observation. The stillness that the Gombe forest achieves in the middle of the night, the hours between midnight and the first bird calls of the pre-dawn, is a stillness that the researcher who has spent nights in the field at Gombe describes as among the most complete they have ever experienced. The lake is audible, but barely. The insects are still. The wind has dropped to nothing in the hour before the shore breeze picks up again in the cooling of the pre-dawn. The forest is in the deepest mode of its nighttime activity, not silent, because the biological community never stops, but operating at the reduced frequency that the gap between the nocturnal species' peak activity and the diurnal species' first stirrings produces. In this stillness, the chimpanzees are sleeping the deepest sleep of the night. The behavioral recordings from the remote cameras at the nest sites have found that the middle of the night produces the longest continuous sleep bouts, the fewest nighttime movements, and the most complete behavioral quiescence. The community is as fully at rest as it will be at any point in the 24-hour cycle. You are in your own deepest sleep now, or approaching it. The sounds of your environment are as familiar as the Gombe forest sounds are to the chimpanzee in the nest. The sounds that belong to the night and that the sleeping system has learned to process as background rather than as signal. The awareness that would otherwise be monitoring these sounds has withdrawn to the maintenance level that the sleep provides, and what remains is the breathing and the dark and the body that knows what to do with both. The lake is lapping at the shore of the Gombe forest. The chimpanzee is in its nest. You are in yours. The night holds all of it, the forest and the lake and the community and the canopy, and the 60 years of watching and the 6 million years of evolution, and the 98.7% of shared genome, and the breathing that you share with everything alive in the dark, in the same patient, unhurried dark that has always been here and will always be here, on the other side of the sleep you are now fully in. The greybeard male, the old adult male whose silver-grey hair at the chin and the sides of the face marks his age in the way that grey hair marks age in the human, is the most experienced individual in the male hierarchy at any given time, and the behavioral record at Gombe has found that the oldest males in the community are not necessarily the most dominant. The physical prime that the alpha position typically requires peaks in the mid-adult years and declines with age, and the old male's competitive position in the hierarchy reflects this decline. But the old male's knowledge of the territory, the prey, the social history of the community members he has lived alongside for decades, and the patterns of seasonal resource availability that the long-term experience of the forest produces. This knowledge is present in the old male in a form that no younger individual possesses, and it is expressed in the behavioral decisions that the old male makes, whose efficiency the research has found to exceed the efficiency of younger males making equivalent decisions in the same contexts. The old female is the same. The greybeard female, whose status in the female hierarchy has been maintained across decades of social investment, and whose knowledge of the forest and the community is the most complete of any individual currently living in the range. The research on the effects of the oldest female's deaths on the community has found behavioral disruptions in the subsequent years that reflect the loss of the navigational and social knowledge that the old female provided. A finding that parallels the equivalent findings on the effects of matriarch deaths in elephant populations. The oldest individuals are the most knowledgeable. The most knowledgeable individuals are the most irreplaceable. The conservation of the chimpanzee is the conservation of not just the population's numbers, but the knowledge those numbers contain. The accumulated behavioral wisdom of the individuals who have lived long enough to know the forest in the full depth that only time produces. The infant that is sleeping pressed against its mother in the nest tonight. The infant that is perhaps 6 months old, that has been outside its mother's body for 6 months of a life that will extend to 50 or 60 years if it survives to adulthood, is already accumulating the knowledge that its eventual independence will require. It is learning the forest sounds in the night from the safety of the maternal nest. It is learning the social landscape of the community from the security of the maternal presence that makes the encounters with other community members non-threatening. It is learning the food resources and the routes through the canopy and the seasonal patterns of the forest, from the continuous proximity to the mother whose daily behavior reveals all of these things in real time. The infant does not know it is learning. The mother does not know she is teaching. The learning is happening in the way that all primate social learning happens, through the observation and the practice that the social environment provides, in the context of the social bond that makes the observation possible and the safety that makes the practice low risk. The infant will be doing this for 5 more years, in the nest beside the mother and in the forest alongside her, accumulating the knowledge base that will allow it to survive and to reproduce in the community whose social and ecological complexity the research has spent 60 years characterizing. The knowledge is being built right now, in the sleeping infant's brain, in the consolidation process that the infant's nighttime sleep, longer and more deeply restorative than the adult's, as the developing nervous system's requirements exceed the mature nervous system's, is completing. The infant sleeps more than the adult because the infant is building more. The architecture of the knowledge is being laid down in the sleeping hours, and the day's observations are being organized into the patterns whose retrieval the adult's behavioral competence will depend on. The sun will rise over Lake Tanganyika in the morning, and the lake's surface will catch the light in the way that the deepest lakes catch morning light, completely, from horizon to horizon, without the shallowing that coastal waters produce. The forest at Gombe will receive that light through the canopy in the dappled patterns that the chimpanzees know from every morning of their lives in this place, and the community will descend from the nests in the sequence that the hierarchy and the social bonds and the individual behavioral styles of 60+ individuals produce, the same general sequence that the research has documented across the decades of the morning descent observations. And the day's management will begin. The alliances will be assessed, the food resources will be sought, the social positions will be contested or maintained. The infant will watch everything from its position against the mother's chest. But all of that is the morning's work, and the morning has not yet arrived. What is here now is the lake in the dark, and the forest in the dark, and the community of sleeping chimpanzees in the canopy, whose breathing you cannot hear but whose existence in the same night that holds you connects you to them across the 6 million years of separate evolution that has produced such different animals from the same beginning. The breathing continues. The night continues. The lake continues to receive the stars. And you are in the rest that has been building since the light went out. In the dark, that is the same dark the chimpanzee sleeps in, and the bonobo sleeps in, and the orangutan sleeps in, and the giraffe and the eagle and the zebra sleep in, the same dark that has always been here for everything that needed it. Sleep now. The morning is coming, but not yet. Not yet.